I think we should start now. Patolia sir, are you here?
Yeah,
Yes,
yeah,
yes. Yeah,
I'm
yes,
here.
fine. Sir, can you please check your PPTs?
Yeah, sure.
Yeah.
Let me know once visible at your end.
Yeah, it is visible now.
Okay. So do you want to stop sharing or keep it
No,
as
no,
it is?
let it be, sir. Let it be.
Okay. Yeah. Yeah, we can start then.
Yes. Respected HOD sir, esteemed speaker, and the dear participants. At this moment, it gives me immense pleasure to extend a warm and respectful invitation to Mr. Jignesh Patolia from eInfochips to join today's online Atal FDP program. Let me introduce Jignesh Patolia sir. Jignesh Patolia sir is a senior engineer at eInfochip Limited, Ahmedabad, with extensive experience in semiconductor technology, AI-driven verification, IP verification, subsystem verification, and SOC verification. He holds a BE degree in Electronics and Communication Engineering from North Gujarat University, where he secured the university's second rank, and an ME degree in Electronics and Communication Engineering from Gujarat University, again securing the university's second rank. He completed his PhD from Charuset with 4+ years of industry experience in semiconductor verification and 13+ years in academia. Dr. Patolia specialized in digital design verification, AI-based verification, ASIC and FPGA verification, UVM methodology, functional coverage, assertion-based verification, and low power verification with expertise in AXI, PCIe, DDR, and advanced verification methodologies. His work includes applying AI in verification such as machine learning based test case optimization and AI powered coverage analysis to enhance the efficiency of IP and SOC verification. He is also actively involved in proof of concept development, focusing on rapid prototyping for semiconductor validation and AI driven applications. Additionally, he has a strong foundation in embedded system, IoT, real-time operating systems, and FPGA-based systems, making him proficient in power-aware verification, system Verilog assertions, and advanced functional verification technique. Before transitioning into semiconductor and AI-driven verification, he significantly contributed to embedded systems, IoT, and real-time operating systems. He has conducted 150 plus workshops covering microcontrollers, ARM, Verilog, VLSI design, PCB design, embedded C, Python programming, robot operating system, Raspberry Pi, and IoT. Dr. Patolia has been actively involved in POC development, enabling innovative semiconductor verification solutions using AI and automation techniques. His work focuses on enhancing verification efficiency through ML-driven predictive analysis. He has guided 21 plus PG dissertations and 110 plus UG projects and has published 46 plus research papers in national and international journals as conferences. As a reviewer for international conferences, he plays a crucial role in advancing research in semiconductor verification. His contributions have been recognized through awards such as the Tele Innovation Award at JEDI Project Challenge, that was at IISc Bangalore, and the Embrace Impossible Challenges Core Value Award. Apart from this all, I know him that he is a very good teacher. Mr. Patolia bring with him rich industry experience and deep insight into semiconductor technology and its evolving role in AI-driven chip design and fabrication. He'll be discussing about smart manufacturing and AI in fabs. On behalf of V.V.P Engineering College and the entire team, I cordially invite Mr. Dr. Jignesh Patolia to kindly join the session. Patolia sir, over to you, please.
Yeah, thank you, ma'am, for this warm welcome and introduction. Yes, only one line is fine for me. By heart, I'm teacher. Currently in industry, but I invested much bandwidth of as per my career path in this academy. So now I know both the pain, industry as well as academic. So I know your pain very well because before these 4 years, I'm part of it. So don't hesitate to ask any silly questions to me, even though it's fabulous or that.
दे देंगे क्या इतना एकदम से ऐसे तेरे पास क्यों करते हैं मेरे को ये नहीं समझ आ रहा
Participants, please switch off your mic.
Yeah, thank you. So, ma'am, I hope my screen visible and slide is also visible. So
Yes, it is visible, sir.
Yeah. So let's first focus on that topic have been given to me, and before that, this entire VVV team is like my colleague because entire Gujarat even know me, but right now it's a thank you very much to VVP team to give me immense opportunity to interact with these 18 states people and academician. And along with you people, I also attended last 3 days session, even though my busy schedule. So I know what is delivered. So till whatever the sessions the people having, the people walk through that entire PD flow and that touch upon some fabrication terminology as well as that some manufacturing material and advanced material as well. So here my target is that what is in the smart manufacturing, what is the role of AI, and then I will be discuss that modern ASIC design flow, okay, how this AI role change the perception or how that ASIC design flow change in that part, and what are these job opportunities in a fabless as well as fab, and which kind of this skill side that is very important that we need to, as a teacher or academician, we need to impart in our students to fulfill that our Vikshit Bharat mission of our Honorable Prime Minister. That is 2047, but let's target up to this 2030. And this one of the slide people are also talking, we have this 5 lakhs of jobs. So we bucketize at last. Let's see how much time permit on that part. So let's start with this our presentation or the talk. So why we are this interested right now? People are or any non-technical people also talking about semicon or semiconductors. So semiconductors why it's matter today? Because it's a backbone of that AI that people are talking about. If you see the today's newspaper and the front page, Bill Gates again has quoted some statement like that. Right now, he, as per his perception, that white collar jobs and blue collar jobs are in a risk. But it's a global level statement. Don't worry for that. We are living in India, and we are that highly adaptive people. So if we again see this innovations from that calculators or that one first that computer arrive, at that moment people are also again that those are associated in the bank. The people, some people's afraid and some people again come forward and the people adapt. So who won the race? Those who adapt those changes, those always win the race. So if right now our target is or everyone target is vitamin M. So our doctor always suggests multivitamin goli, but here this vitamin M means vitamin money. So that's why the first session, Mr. Nilas Ranpura again talking about this economy. And here ultimate goal is nothing but that lies to at end of the day, it's money. So money is not everything, but it's a fact that everything need money. So even though suppose you are the good researcher, you have this 500 papers and 50 of the patents, but we need to accept the truth that suppose during the payment of fees of your child, you have to pay money. So right now, everybody interested in this vitamin M, and that is our not main objective, but ultimately it moving towards us to that. So right now we are interested in this entire country, and this entire country policies are talking about this ISM, Indian Semiconductor Mission, and that's our national priority, and we need to contribute by directly or indirectly. So that's why these are highly investing this money to conduct such kind of sessions. And right now it's a good thing the people that choose that most of the peoples from that industry. So I highly appreciate that efforts from that entire team. But here, this India, yes, it's true. We need to accept that industry drive this academics, but in a majority of company or it's a good country, it's true that in academic drive the industry. So change will happen, but let's see. But it's a 2016 truth, January. Let's keep in the mind. So this is the backbone. Right now, we are talking about AI. We are talking about the big data. We are talking about this deep learning, machine learning, everything. So no digital transformation without semiconductor chips, and that's why everyone talking about semiconductor. That's why the semiconductor matters today. Second question is why semiconductor manufacturing is unique. So it's not like that the conventional factory and it is called fab because that's fabs operate at atomic scale. So here in the normal factory, suppose it's manufacturing car or suppose plastic machine or suppose plastic spoons and the product that we can see in the factory. So we can see this entire product in by our naked eyes. But that is not truth for this fab because here from the last 3 days and before that you must heard this we have these trillions of transistor on single wafer. So what is the size of that wafer? It's very, very small. And in this, we are talking about we have trillions or billions of transistor. So think about that the size of transistor is nothing but thinner than our high hair. So the germs and the particles are not allowed in that. And once we are in the fab, if you are watching the video in the YouTube, if we are not get chance to visit any fab till that, but if God wish, then I wish everyone can visit such kind of fab once that setup available in Gujarat. But till that, we have that videos available on YouTube. So people are like that astronauts. Why? Because it's the small particles or germs, even the smaller than virus, it's not allowed because our transistor size is nothing but smaller than virus. So that's why it's so unique manufacturing, and that's why, and it's very costly as well. So this entire field is costly. So what are the challenges that again you can figure it out from one day or second day session? Challenges in this traditional fab manufacturing because we are going to talk on the smart manufacturing. So before going to the smart, we need to understand this traditional fab manufacturing. So here yield. So you people now have very well know this yield loss. So everyone is working on that yield. So this yield is nothing but number of good chip divided by total number of chips that you are going to manufacture from the wafer. So yield loss that again is high that we can improve with help of smart manufacturing and AI. Equipment downtime. So in traditional manufacturing that right now we can't see any facility. If that equipment is goes down, then again we need to wait for that. So if we can take a help of AI or that smartness or the technology is available right now, and if we set up that early fault detection mechanism or suppose early maintenance mechanism with the help of AI, then we can prevent those issues at early base. Process variability. So here that we can discuss more on that. And here massive data but undeteralized means here we have more data. But if we are not conclude anything from this data, then all these data are meaningless. So, but yes, data is nothing but it's a food for that deep learning and machine learning. So this is very, very important. But without data, we can't do anything with help of this AI because AI is nothing but prediction. So that we go with the moving the further slide. So before again deep dive into this, let's understand these key components of the semiconductor industry. So one component is the chip design. Second is that verification and testing. So here in verification and testing, I covered that design verification as well as that PD. So whatever that verification and testing, that again fall under this category. EDA tools and software, that is also one category. Foundries and fabrication, that is our today's interest. Packaging assembly is also part of that manufacturing, and semiconductor IPs and startups. So these are these broad sense in this semiconductor industry. And from that now, what your thought process that we discussed at last is, suppose if you are talking about, or we are talking about 5 lakhs job available up to 2030, then how many jobs that you are expecting in each? And again, if we do the reverse engineering, then we have clarity, and then we can derive this truth, not rather than whatever the people are saying that so and so opportunity in so and so field. But if we again brainstorm in a such a way, okay, which are this broad sense of area, again in this broad sense of area, what is a requirement, what is the current status, what is going on the upcoming days, and does it really require such kind of jobs or not? Based on that, we can stated or quoted our statement. Otherwise, it's always become future, future, and future. So as per the title, the recent trends in the semiconductor technology. So there are a couple of recent trends, but I bucketize only this 10 for this session. And in this session, we are more focused on this human-centric AI-driven semiconductor growth. Second, as a part of the smart manufacturing, we are covering this sustainable and green manufacturing as well. At chiplet, we touch upon little bit. And you can see some political people are talking this this advanced material as well. We touch upon that, yes, part of research that people interest, as I heard that in couple of questions people ask in that part as well. So what is beyond that 2 nanometer, and what is the limitation of the CMOS? And not CMOS is now not but people adapt that good as well as present. What is AGI? Risk V is not part of this session because it's not aligned with this topic. Supply chain resilience, it's ultimately byproduct that of the say we can say. And integration of this AI chip design India tools that I will cover in while we discuss that modern ASIC design flow. So these are these recent trends in the semiconductor as per my perception. There are a couple other as well. So it's not like that you need to restrict only this slide. Yeah, so that again, majority of time, I will talk about this industry 4.0, industry 5.0. Why? Because the smart terminology that again fall under some part under this industry 4.0 and some part in industry 5.0. But nowadays, for this sustainable stuff to achieve that, people are mostly aligned toward this industry 5.0. So that's why I make this presentation more aligned with this industry 5.0. So that is called recent trends and justify titles and objective of that organizer committee. So yeah, journey start with this industry 1.0, 2.40, 3.0. Up to this automation, electronics, informatives are there. But now that from this 4.0, people are talking about IIoT, that is industrial IoT, cyber physical system. People are talking about cloud computing, and in that also people are talking about robotics. In case of industry 5.0, it's people are also talking about robotics, but here some robots are changed to align with objectives set up by industry 5.0. So there are main three objectives for this industry 5.0, and out of the three, one is human centric, second is sustainable. So in industry 3.0, people are mostly play with this automation testing, electronics, and IT. Second, in industry 4.0, smart automation. So here this IoT comes into a picture. AI also is part of that, but here in industry 5.0, we are highly depend on this AI, and that's why we are discussing this role of AI in this session as well. So if again we are discussing or bucketize more towards this feature wise, then main theme that already we discussed, the smart automation for cyber physical system, and here is more about that human centric feature. But here, if you see Industry 4.0, 2010 to present as well, and Industry 5.0 also 2022 future. So here it is a present and we are talking about future. So that is justify our present date as well as what is upcoming in the next 5 years or 10 years. Here key technologies. So we are not most now interested in this 3.0. We are highly interested in 4.0 and 5.0. So here this key technology, IoT, AI, ML, cloud, big data, autonomous robots. So here these are autonomous robots, but these autonomous robots are converted into these here cobots. So these cobots are nothing but collaborative robots that can work with human with a safe environment, and it demands some changes in the VLSI or semiconductor industry that also we are going to discuss. So right now we are creating this context why we are discussing that industry 5.0 in this semiconductor. The production style also here highly automated, but here human plus machine in focus. So don't keep an eye over here. Please keep eye on present and future. So focus is nothing but connectivity. So here through IoT, we have Bluetooth, Wi-Fi, Zigbee, LoRaWAN, all these connectivity protocols that people discussing in session of IoT. Also real-time data, because for the machine learning, reinforcement learning, we need to provide real data, and based on the real data, we are updating ourselves once we have the feedback from our upper management, our HOD. Suppose if we are assistant professor, our hierarchy is HOD. So once we receive some feedback from HOD, then we immediately think on that, and if we are aligned with that feedback, then we improve ourselves. Similar way, head is under control of principal, and suppose principal suggests something to HOD, then HOD is also aligned with that feedback, and from real data always human learn. Similar way here, with help of this reinforcement learning, we need to focus on that part as well. But here in industry 5.0, it's a more on human value, resilience and sustainability. So these three pillars, main pillars of industry 5.0, and that people are publishing a huge paper on this based on these three objective. Role of human here, machine centric, but here it is a human centric with help of cobots. Here data usage, big data, analytics, cloud, but here edge data is also important, and here human decision making, because here robot and human both are working together. That is the main role, because it is a human centric. So in fab now, some automation right now we are seeing, but in the future, once the Fabrica smart manufacturing adapt that industry 5.0, at that moment we are seeing that if we are alive in this planet, because we don't know what happened in the next hour or the next second. But yes, if we people available on this planet, then soon we can see such kind of industry in this India itself, in that this human and robot work together. And there are a couple of factories are running, but right now we are talking about the smart manufacturing in the fab. So in the fab, right now this industry 4.0 or this 3.0, but this 5.0 people are also adapting or trying, because here green circular economy as well. So example that we discussed. Yes, so here in the nutshell, we can see this transition from this 3.0 to 4.0. That is nothing but smart automation. So that again mainly IoT, AI, and data analytics, intelligence factories. But in case of industry 5.0, we are more towards its human centric, and we are going to build that smart ecosystem. So this conventional ASIC flow that you people are very well know based on this last 3 days session, because as we know that any chip right now we are interested in this semiconductor industry. So there are majorly two kind of company that you people heard. One is fab, second is fabless. So this fabless is nothing but they people work up to this GDS2. So like that PCB design, we have to send that Gerber file to that PCB manufacturer. So similar way here we want to manufacture or fabricate our that IC or chip. That is what our intents, that we have start with our idea. So before that means going to that fab smart manufacturing, we need to understand this entire flow, but that is already covered by some experts, so we are not touch upon those part. We are only touch upon this part which are new stuff at each level, and that change this conventional SE flow to modern SE flow. So that's it's avoid to repetition of content, and you have this new flavor today. That is what my guarantee to this all participants. So here you people very well know this up to this design functional verification. So right now I am working here, design verification. So here RTL synthesis also people covering. So each stage people covering in that last 3 days. So here, yes, first job it is available in the fabless company. So there are a couple of companies available in the market. So again, these companies are divided in these two parts in fabless itself. One is service and second is product base. So here again, the question to everyone, or please brainstorm on it. Up to GDS2, there is no existence of chip. Up to GDS2 in this entire SE flow, there is no existence of any silicon wafer or anything else. Here only you are preparing your map, like suppose even though you are not purchase land itself, but here up to GDS2 you have this clarity. Okay, to build my home, I need so much amount of land. It's in terms of okay, what should be my size of floor, and on the top of that, I would like to build either apartment, that is called chiplet. People are again introducing this word or throw this very booming words in the last 3 days. But here, my dear friends, up to GDS2, it is the truth that up to this, there is no existence of physical chip. And your manufacturing start after this GDS2. So if right now we have any idea, if I want to manufacture or suppose build the chip that is not exist in the market, but it is my specific demand to suppose align with industry 5.0 objective, then we need to start from sometime from here. And again, my question, so this is the first question to everyone. Okay, service-based company and product-based company. So it is a fabless. There is no physical product available in this. Then what is called product? I hope are you with me and my words? So here in the industry, I divide into two parts. One is fabless, second is fab. Fab is nothing but at that you can fabricate, you can manufacture, you can package, you can taste. Everything is there. Machine, big machines are there, and that astronauts are there in this, and that things is happened once we provide this GDS2 to this fab. But before that, we have this fabless, and in fabless again we have two broader sense. One is service based, second is product based. So again, my question, or we need to brainstorm, because ultimately we need to convince our student or convey whatever knowledge that you people gather through these 6 days to our students. Those are nothing but that our main power, workforce development. So that's why this we are here. So at last, suppose if you have question, then definitely I will cover. But meanwhile, brainstorming it in a fabless, which are the service based, or what is the role of the service based companies. But in up to this fabless, even though we can't see that any physical device, then what is called product based company. In fab, again in one of the session, it's covered very well. Which are these skill set required, and which are the streams that associate with this fab. So chemical engineering, definitely this physics, because here we are a role of this yield engineer, production engineer, all those engineers we need, but on top of that, we need these chemical engineers as well. So this ASIC as enablers for that industry 5.0. So up to this, let me take a pause, and if you have any questions so far, then please let me know. Otherwise, let's continue our session, and I will collect your questions at last. So I will try to finish at 7:15 if possible, and 15 minutes I kept, or half an hour I kept for that your question answer. So I seek as enablers for industry 5.0. So here, please look at this. It's priority system that we work with humans, but not instead of them. So Bill Gates rightly said that global statement today in due to this AI, it's white collars and blue collars jobs are in the risk. But those who are ahead or suppose ready to adapt the change, they people win the race. That we need to adapt, and with that we need to digest. So here this AI device. Now look at this. Now from modern system, from autonomous robots to edge AI device, and that require high performance, low power, secure, and application optimized chips. So who demands this? This is nothing but demand for Industry 5.0. And which are these objectives for Industry 5.0? Human-centric, sustainable, and resilience. So that's why here last. So this is also a new research area, neuromorphic design. So I have dedicated slide as well for this. So here again we need to design some enhanced safety and fail-safe features that integrate into hardware. That means it's nothing but for more towards automotive as well, and as well as this for manufacturing. Because right now we are going to tell about the smart manufacturing, and in the smart manufacturing we are using those chips. And what happen if we are not able to provide security? Then anyone, our enemy, then hijack or suppose introduce that bug in that design, and they can stop entire fab. So again after that we are helpless, and it's also affect that our economy. So here while adapting the smartness, there are a couple of steps that we need to taken care, and that arise some changes into this ASIC chips. So now let's discuss that modern ASIC flow with respect to conventional. So whatever that left hand side, that's nothing but conventional design flow that all people's discussed. But my topic is what is the role of AI. So that is nothing but right side here. So whatever that flow that you are seeing in this side, it's a conventional flow. And in top of that in each layer, so flow remain as it is. But here we need to see that which are this new stuff that add on to fulfill this requirement of 4.0 and 5.0. So here's system specification, traditional. It defines this functional performance power area requirements, but Industry 5.0 adds this stuff. This human-oriented use cases, safety and ergonomics. This is very important. Ethical AI constraints, and we need to target this because while designing these specifications, this energy limits, low power is possible or not, power safety is there or not. So these are this demand raised or raised by this 5.0. Now second stage, everyone knows architecture design. So whatever the system specifications that is on paper, now this RTL engineer or architect, we have this dedicated position in this industry. One is that is called solution architect. So solution architect now walk through that system specification and then come up with that high level architecture exploration, and they have meeting with that entire RTL team, and then who have experience. So here now in that we are using now AI tools to help to find optimal PPA. So it's not again rightly said AI will give you everything, but it will help to reduce repetitive task, and it having some suggestion. Human engineers remain in control, but human AI teaming and sustainability scoring for architectures. Third is again RTL design. So here RTL design people are talking here you need strong foundation of digital electronics. Second, strong foundation of that Verilog or that VHDL. Nowadays, people are using system Verilog as well for the design. But if system Verilog in use design, so system Verilog used for that verification as well as for design perspective. So if your goal is design, then we need to use only that synthesizable constraint or feature that is supported by SV. Similar same statement also applicable for Verilog. So this Verilog, once that if SV is not didn't exist in the planet, at that moment people are again write that code in Verilog, and as well as that people are again doing that verification. So now try to understand in any ASIC chip and the design cycle, design verification is a bottleneck. So 60 to 70% of time in minimum case, any scenario, minimum 50% and maximum 60 to 70% of the time of entire ASIC chip that we need to devote to this verification. And again, we are talking about that job, but while designing that syllabus or that curriculum of our academic, nobody take care of such kind of courses of that verification. That is the truth. So I repeat once again, in the if you are see the entire ASIC chip cycle nowadays, I'm talking about 2016 up to this, whatever ASIC chip, you can refer any paper or you can visit to any expert. Those are working in this field for more than 25 years or 30 years or 40 years. Then you heard that verification is a bottleneck for this entire ASIC chip, and need to invest this 650 to 60 70 percentage time of that verification, and it is bottleneck. Why? Because RTL engineer is again design this Verilog code, and after that he announced that I am done at my end and my design is good. But who give the proven that or certificate that whatever that code written or suppose features supported by this RTL code that are fully aligned with specifications or not. So that's why here we need this functional verification. So here you can see the test benches, UVM. So here in this functional verification, nowadays in recent, there are two stuff. One is conventional, means simulation based, or you can say dynamic verification, and second is formal verification. So this is also a recent trend in this verification. So before recently we have conducted one FDP at that IIT Jammu, and I'm also that invited for that to deliver the session on this specifically for 2 days with hands-on on this formal verification itself, because the demand is we know this verification, but here that is a customized FDP for that PG, UG, PG and PhD holders. So here we touch upon that part as well. So here, what is new in this verification? Even though in functional verification, nowadays, earlier, people are using this GVM, Linux, so that the tools are there. But once your students come into the industry in this right now, they people always play with Linux. And in Linux, we have editor like you suppose GVM editor is very famous nowadays. So the people always writing the code in this GVM editor. But now with help of this AI, again, in the Windows, we can use this VS Code. In this VS Code, that some company buys a license for this ChatGPT or the AI agents. And while writing, now try to understand what is the role of AI in this again modern ASIC flow. So in a functional verification earlier, what we did, entire stuff that written by this verification engineer. But now AI generates that stage scenario. So we are again suppose providing that specification to the tool and ask now from this specification I want to verify so and so feature. So out of this 10 feature, I want to verify one feature. Can you please enlist all possible scenarios? So that tool will give within a fraction of 2 minutes or 3 minutes. After that, again, verification engineers walk through it. It's again because he or she has knowledge of that entire specification, and he validate that. So validation is required. So there is no, it is not like that in entire design verification job hand over by or taken care by this AI. Yes, definitely we can say that we can optimize that, but we definitely require this RTL engineer, because it's not like that we can say directly to this prompt to right now I want to design Verilog code for this SOC. Can you please provide that? It's not like that. So similar way, same approach or same statement is valid for this functional verification. So here I hope this we are also interested in the coverage. So in coverage, if we are prepare very good coverage file for particular one protocol, let's say for the 16-bit chip, and then suppose it's converted to 32-bit, then we can assign this job to this prompt. Okay, this is my file that is for the 16-bit. Now my feature is changed. to 16-bit 2 upgraded to 16-bit to 32-bit. Can you please modify this file to align with 32-bit? So such kind of jobs right now we are assigning to these AI agents in this functional verification as well. Similar way, synthesize. So you have very well good clarity based on these last 3 days what is called synthesize. So in the synthesize tool, so companies like right now the tool manufacturing or tool providing company, not manufacturing, tool providing company, that having one dedicated post as well, tool validation. So that is also one job role, tool validation. So means they are providing this AI feature in the tool. But as we know, before publish this feature to the customer, they have to validate. So there is a two stuff. One is development, second is validation. So there is dedicated designation or job profile available in the some company for this tool validation as well. So in tool now the people providing this AI, artificial intelligence or machine learning, that can optimize for sustainability. Here, so this is also role of AI. So I'm covering both the stuff, role of AI as well. What is the change of industry 5.0 in this ASIC flow? So whatever that we have this entire stuff in our mind, so we can upgrade those stuff with help of AI. So we can guide our students crystal clearly. Now for planning, so up to this now started with that physical design. So that you people now very well know for this floor planning. In this AI proposes optimal layouts. So it's right now under testing phase. So it's not proven, but yes, we can say that this AI is already now part of EDA tool and it does help a lot. So this verification and RTL here, it's not more towards this design verification job for tool driven, but this DFT that is called design for testability and PD here definitely you require some knowledge, but it's more dependent on the tool base. Here right now here it's depend on human efforts, human intelligence. It's required thought process here required. As a verification engineer or as a RTL engineer, first of all you need to go through this specification. Here good amount of patience needed. It's so that also we need to inculcate in our students, not right now focus on technical skill, this is stuff, but before that some skills that industry always demand. That first skill is self learning, because here we don't have any time to guide them. Let's say that we are teaching everything in the classroom. So first and foremost requirement that we need to inculcate our students is the self learning. Second, we need to teach them how to digest failures that never happen. It again build the patience. So means some bugs are there. So it's not like that faster output. So it's not like that your Arduino coding or that your controller coding, once you develop the code for the LED on off, you dump into this and your LED is flashing. So if the students having that attitude, then please say this industry means semiconductor or this ASICs not for you. Please, you can go with either IT fields or that digital field or embedded field, or you can go with robotics, or you have your own business. But sorry, here if you want to guide your student, then please convey them you should be passionate, because here as a RTL engineer there is a very, if as a fresher the people have a chance, that's good. But after the people always demanding 3 years or 4 years of engineers, because they are architect of this entire chip. And these RTL engineers have to meeting with design verification engineer, as well as the people have to again meeting with DFT, as well as this RTL engineer having some meeting with that PD. And after this, during this fabrication, if that is like that, then the people have that as well. So RTL engineers is has to little bit knowledge of. So if again students come, if I want to be RTL engineer, so it's not like that only very long. He or she should know at least touch upon verification. He or she should at least touch upon what is a PD flow and which are this going on through, and he or she should at least know of this FPGA emulation as well. So this is a crystal clear demand of industry. That is what I can see based on that my best experience. As second part of this digital verification, here this is a part of its life of programming. So those students are had this transistor, because sometimes the people, I don't do, wait for this I, and that's what happening in this channel diffusion and this heat propagation, and then what this BJT transistor, everything. Even though the people can build their career in this digital verification, because here in system verilog we have these OOPS concepts. In a UVM, that is nothing but universal verification methodology. That is a framework, but it is again highly right now based on this system verilog only. And here in day-to-day life, the people have to play with programs, means codes and signals. But here, this is not straight away C programming. It's not sequential coding. It's a concurrent language. So strong foundation and fundamentals. So that is also missing. So again, we need to focus on fundamentals while delivering our session. So once that people come to us, then we ask the question, because here, if you start your presentation, first you clear what, then second question, always you need to justify why. Uh, so I convey my disclose my methodology or my perception for engine sastra at last. But let's first finish this. So for planning in placement, that you people very well know. Sign off, very nicely covered yesterday. And then this fabrication. So in fabrication, in a traditional chip manufacturing, but now industry 5.0 demand is all this stuff. So now let's walk through this each and every requirement. Yes, this packaging traditional way, but here bio-based packaging, chiplets, 3D IC, AI-driven test coverage optimization, and human-friendly test interfaces. Deployment, for this deployment, we are thinking on, we need to think on this low carbon logistics, and also that personalized variable and IoT devices. And definitely this in the normal ASIC flow, it is not part of, but now during this modern smart manufacturing, this digital twin life cycle also come. This predicts this chip aging and failures, and guide this recycling and use, and supports the sustainable life cycle of management. So this is nothing but part of AI, or role of AI in this semiconductor as well. So which what this industry 5.0 impact on this ASIC? So first is human centric, and that ASIC impact is safely critical circuits, ultra low latency chips, and how we can design this ultra low latency chip. So with help of CMOS, definitely answer is yes or no. So that we need to again think on that, which kind of materials or which kind of technology now we need to adapt to fulfill all this requirement. Sustainability, so we have dedicated slide for this green fabrication as well. Intelligent system, massive lectures on that. Cyber physical integration, so secure hardware modules and trusted IPs, that is also needed, because if we are purchase some suppose drones, that again Nilesh sir is talking about economies on that from these other countries, and suppose it's not trusted IPs interior on that, something the people install in terms of hardware, in terms of software, okay, based on that need, or the people can hack those drones anytime. So this is also a requirement, and that's why we are now, we are late, everyone said, but in India has power that nullify that gap. So it's don't negative impact on that part. Focus on whatever this country is giving to us, and that resources provide to us, and uh, let's try to push our hand in this mission. They personalize this rapid chip prototyping, because now ISM provides. So you can see now from Gujarat that recently, before this 6 or 7 months, I don't know exactly number of months, but NIT Surat is also fabricated, one of the PhD scholar fabricated that chip from concept to that entire IoT product for that healthcare. So this is nothing but project under did by that ISM mission, and that sponsored given by this government. So we need to think on that part, and we need to adapt it. And human AI collaboration, that AI based EDA tools. So what industry 5.0 brings reveal as a design? Everything now is clear. So let's quickly now go through it. It's advanced chips. It's also demand. packaging technique and manufacturing chip. So it's again VLSI design. That's Industry 5.0 brings into this VLSI design. High level, energy efficient, lithographer, and this is very important, new materials. So those are this again interested. I want to become a scientist, or suppose, sir, my interest is only that manufacturing or this material. So it is a field for them, or new research direction or gap to those people to fulfill those gap. The people also work on this, and the people publish their papers as a part of their to fulfill criteria C for the promotion or that anything. Yeah, so which are these key technologies driving Industry 5.0? So first is a neuromorphic VLSI. So you can think on that, can mimic the brain-like processing. So this is also a role of AI. Okay, what is that? AI is nothing but how human think that we want to mimic with help of that chips or that machine, and enables real-time, low-power cognitions robots. So this is a one field or kit VLSI technologies. Second, edge AI accelerators. So that DSP enabled ML cores, you can say, the real-time perception in cobots, AI powered variable for safety monitoring, smart manufacturing sensors with on device anomaly detection, energy efficient AI. So those are these accelerators that again technology to driving Industry 5.0. And these are some examples that again align with that our today's talk on this FDP title, that Google Edge TPU, that Apple Neural Engine, Qualcomm Hexagon DSP or NPU, Intel. So all those are now familiar. So people also touch upon this 3D IC and chiplets. So this is also one demand. So now this is the like we are manufacturing that right now. We are also having this parking problem. So we are also now in the stack wise. So similar way, that concept now adopted by this technology industry as well, and people are also that now chiplets. So one of the recent protocol that in a lesser slide, UCIe, to interconnect this chiplet. So one we have this PCIe for this high speed data transfer. This is a serial protocol similar to this UCIe. So spec is released in the last year only. So right now people are working on this IP or VIP, and the people release soon to validate all those stuff. Secure hardware, that is also demand. Ultra low power IoT, SOX means SoCs. So here, yes. Now, how this VLSI design methodology changes in Industry 5.0? So first is user-centric chip specification. So here now user is defined his own objective. Okay, I would want to do so and so, and then so that's why the example of that NIT Surat. Okay, they people define their his own objective, and based on that from idea to that entire product or application. So the people tested with help of Android application that entire chip. If you walk through that the news or that videos. So this is nothing but that proven user-centric chip specification nowadays. The chip must support fast responsive interaction for end users. Chip must guarantee strong privacy for personal data. That is must. And chip must support that industrial or edge reliability for enterprise users. Some of the examples that more relate for this AIML. Second, sustainability aware that EDA tools, because without that EDA tools, how we can achieve this time to market? Because everyone interested in vitamin M, and for this to achieve this vitamin M, we need to reduce this time to market. So if you are first in the time to market, suppose UCIe protocol is the first. There is, for example, no IP available once spec release. There is no VIP available once spec release. And if you adopt that, and if you publish your IP, proven IP, that people can reliable and fabricate that chip based on that. If you're VIP, so people can validate this or verify those SoC that's having this UCI protocol. If you are first, then you can demand a huge money from your customer or clients. So this is again that sustainable aware this EDA tools, and we need to understand the time to market as well. So fast time to market using AI in EDA tool. So why AI in EDA tool? So this is the answer to objective is faster time to market. Otherwise, if you're not integrate this AI, then without AI, people are also manufacturing the chip, but with help of AI, now we want to pass the process and to reduce this time to market. So this is very important, weeks to hours before AI. This automatic for planning using AI, but we will not fully rely on that. So here we definitely need some expertise. So whatever people having skill, and that's why our prime minister always focus on skill based, and NEP, that is nothing but national education policy, that is also more focusing on skill. So if you have suppose degree of BME, PhD, anything, you are in industry, suppose some task is assigned to you, but you are not able to complete within a timeline, then that your whatever the degree that you are having, that is a useless at that moment. Yeah, it's definitely helpful to make a space at one company. But once you are in the company at that moment, we need to adapt whatever that recent trends and whatever these upgradations coming from this world, that we need to learn. So learning is a endless process. So whatever degree that, yes, for academies, we definitely require at least PhD. But nowadays, up to in industry, currently BEC is a bare minimum requirement, or this bachelor in this particular domain based on this job description. But this NEP, once we have the fully implemented this NEP, after that it's all this perception always also change. So I'm not talking telling that this your job is also in the risk, but whatever that changes adapted or required for this NEP, please be aware early stage, so you can prevent that risk at early stage. Otherwise, your job is also in a trouble. Then with AI, Google's deep RL commercial AIDA. So here you can see this 20x speed up with help of AI. So AI is right now people are using for that faster. So Google uses AI-based floor planning for tensor processing unit, and this tensor processing unit, that those who are from this computer background, the people know in this deep learning it is highly used. And right now these all companies that Google, like Meta, that Tesla, the people are also interested now that on chips. So that is called nothing but user-centric chips. Why the people nowadays interested? Why not early? We need to brainstorm on that. Now AI-based PNR optimization. Let me go quickly. So Synopsys is again major player for this EDA tool, and the people now again adapted this AI. The people have that AI agent. So Microsoft also now in this chip design, the people also use that AI extensively in this entire ASIC chip. So we can say in nutshell, right now AI is everywhere. So we don't deny that part. Definitely we need to accept there are pros and cons that, but if you want to stay in the race, or if you want to win the race, then we need to adapt AI as soon as possible. This is a feature, original time, AI after AI, and gain. So that already discussed. So this is again, you can conclude that part. This how VLSI design methodology changes in this industry 5.0. So VLSI is nothing but backbone enabling the industry 5.0 technologies like cobots, variables, personalized electronics, sustainable intelligence system, and all of this field suppose sometimes require that user-centric chips, low power chip, high power, sorry, high um, faster chips, and secure. So this ASIC has enablers for this of industry 5.0. And here this priorities for this work with human. I think this slide is repeat, so let's skip that. Yeah, so this entire stuff, that's whole idea. Okay, from this we are now talking about from idea, no, not here, customer application ideas, idea to this entire product level. So in the first keynote session, we I've seen this couple of products, but this couple of products who is a backbone, so that backbones are nothing but chips. And right now, people are talking about this entire chip. So this is nothing but our application specific integrated circuit, and this is our manufacturing process. So now we are interested how this traditional converted into this smart manufacturing. So what is a smart manufacturing? So it's cyber physical system. It requires, it need to add up these digital twins. It requires that AI driven decision making, and we require these connected tools and sensors. So again, that is more towards that human centric AI. So here ethics require, we need to require support that technology, and we require all the moment human. So this is nothing but this human centered smart manufacturing. So here we have design phase, here we have this production phase, and here we have this maintenance phase. And each phase, to convert this traditional into the smart, we need to take help of AI data management or collect AI based geometry or optimization. Here you can see optimized production safety with help of that cobot. And here this nothing but ML, predictive maintenance. Here safety is nothing but demand for this industry 5.0, and that is under fall of smartness, and also AI based human machine interaction. So this is the role of AI in the future once we have this entire smart manufacturing in the fabs. The person wearing a clean room suit is operating it's very well known. Robotic components and visible indicating automation and AI driven manufacturing. And environment is clean, bright, organized, typical of this class 1 to class 100. So we are not going to depth of this. What do you mean by these classes? So what is the challenges in this sustainable manufacturing? First, data privacy and security. So cyber attacks or data leak can compromise operational continuity and violate worker privacy. So that we need to take care. That is a challenge. Second, energy efficient and carbon footprint. So sustainable manufacturing require this energy aware AI solution. So this is a challenge, and we need to come up with that solution. So worker, so these are these areas that that we can think and we can work upon, or we can contribute as based on your whatever skills and support available with your research scholar or with your organization or that with a nation. Worker machine collaboration, also that is a challenge in sustainable manufacturing. So factories succeed when humans and machines complement each other. So it's not like we are right nowadays running factory with help of only humans or with help of only machines. Nowadays, this fabs is working earlier also with help of this machine and humans, but right now at that earlier machines and human both are isolated. So there are some machines or equipment are not safe, or robots are not safe. But now industry 5.0 provided safety, so human and machine can work in the same room or in the same space, and that is nothing but collaborative robots. Yes, this is also challenge ethical and transparent AI decisions. This again service design for transitioning to industry 5.0. Yeah, that one is the green fabrication. So let me walk through quickly. So everyone might be knowing this green fabrication is a practice of using this eco-friendly, energy efficient, and resource conscious process in the semiconductor manufacturing to minimize environmental impact. And we are focusing on this reducing chemical waste, lowering energy consumption, recycling water. So this ultra water require, and after that there are huge chemical mixing with this water, and we need to think on that as a green fabrication, how to recycle and how we can utilize for other purpose or again same purpose, but that should be not thrown straight away. So that is also come under this green fabrication. Yes, so this green fabrication always that reduce carbon emissions, lower water and chemical usage, increases energy efficient, toxic, and comply with these globally standards. So standards are there. We can go over there if required for this, those who are highly interested. So what is the approach for this green fabrication? So energy efficient fabrication tools that we need to use in the smart manufacturing. Second, water recycling and conversion. So closed loop water cycling that taken care. Third, low toxicity chemical and gases, because here we have to use this gas and chemical. Without that, its cheap manufacturing is not possible. Renewable energy integration, so solar and wind energy powering fabrication plants and smart energy grids for the load balancing. So in one of the session that expert is taking that, telling that if you recall his word, then it required that power consumed by one state. So here, that's why now we have this good uh, infrastructure in terms of this green fabrication as well, uh, for this in terms of energy. So waste reduction and recycling, that is also needed for green fabrication, and green packaging technology, that is also needed. And last, I think, but not least, that digital twins for sustainable manufacturing. So here, this AI-based simulation to optimize equipment usage, chemical flow, process temperature, cycle time, that all these things that you need to see through this automation. But again, on top of that, you are also taking help of AI. So why green fabrication matters? So it matters because we want to fabricate eco-friendly chip. We need this cleaner manufacturing environments. We need this long-term economic and environmental stability. So ultimately, our interest is that vitamin M, but we need to also take care of this environmental, because if our environment is dirty and if we are living there, if we have huge amount of money, then it is useless for us. So we need to balance. So reduce carbon footprint of AI and edge devices. So here companies practicing green fabs, people very well knows. So here this roadmap ahead. So here present we are talking about this 3 nanometer and 2 nanometer of the channel width. Now people might be goes into this Armstrong, might be in this year or next year. In 2030, this optical and silicon, and next 10 years or coming years, it's already there, but it's not in a huge amount of. Future is for this few SoC integration. And it is also again new subject for this quantum computing and this quantum electronics. And once you go through this physics behind this quantum, again, you feel like that once we watch the movie, like after that, if we are alive on the planet, then we can see some kind of life story. So soon we can see the robot movie from the Rajkot in this within the 5 years, because yesterday or day before yesterday, you can see in the newspaper on traffic police again appointed by this China humanoid. So similar way again, there is not again that Sophia having that citizenship. So again, days are not very behind that we can see couple of that movies that we see. Then again, we need to compare whether we are in that seeing movie or we are in this live. But for that, we need to pray to God. We need to extend our this life. The road ahead, this quantum electronics, this is again new era. So those are researcher or the people also work on that part or think on this part. So ahead is this quantum electronics, next generation sensor for smart factories. This quantum electronics enables quantum magnetors, accelerators, ultra precise clocks, and single photon detectors. So beyond CMOS, now, because as I promised in my session, we touch upon this what is present and what is the future. So that now people are think it's already started beyond the CMOS, this emerging architecture, emerging device process, and emerging materials. So these are these requirement. Who demands all this big data, IoT, and trillions of these edge sensors, deep learning and artificial intelligence, robotics and automation systems. So up to this, we are good in this BGT, MOSFET, and CMOS. After that, you people come through this terminology through this say 3-day session, and 2 days, let me raise the coin on this quantum dot cellular automata. So this is nothing but beyond this 2025. So this quantum dot cellular automata. So I'm not covering entire stuff on this quantum, but let's see how it look like. So here it is latest emerging technology that provides very efficient computational platform than CMOS. This is a statement that you have to keep in your back pocket. So we are not discussing that physics behind this QCA, but I'm capturing for your record purpose. So QCA trend. So it's not like that again new, but again some company like you can see over here, qubit quantum processor that IBM having as well as Google is also using. So next IoT devices or these embedded systems that again having Q processor, QSOC. Right now we are talking about SOC, that is called system on chip. This is I might be with help of CMOS or this other material, but if we are take help of this quantum electronics and chip manufacture with help of that, then it is based on this QSOC. And it's very nice, but right now its cost is very high. That's not mid to this product, and that's why not everyone using that. So this is a quantum dot cells. Later on, you can walk through the research paper that is available in the repository. This is a majority gate. This is NOT gate. This is a NAND gate. And you can see this area comparison. So like that, you can build your this any digital circuits with help of that simulator available for QBot, and you can also publish your paper for this or contribute in that in this. You can see area used by this QA is very less than that area used by this CMOS. Here, this is very important. For this QA architectures is support that could operates at the density, but at 100 gigahertz without melting the chip. And if our CMOS chip operate this frequency, our chip is definitely melted. So software tools for QA, you can take a help of any AI tool, ChatGPT, which are tools that are available for this. So the people again provide the entire list. So here this QCA designer, QCA design E, QCA Pro, you can start with help of your MTech students, BTech students, or PhD based on your requirement and based on your objective. So objective should be clear. What is your objective? Whether your objective is only research paper for that, or your objective is a product, or your objective is contribute in the future. So this quantum AI is first word, and this now quantum electronics plus industry 5.0. So ultra efficient, sustainable computing we can achieve. Human-centric AI acceleration, that the quantum AI, QI improves this pattern recognition, optimization, all those stuff. Let me complete this very quickly so I can take your questions, because anyhow I need to wrap up at 7:30 due to other commitment. Digital twins. Yes, this is example. So it's where I'm not talking this only that on the air. So I'm talk right now. My talk is covering whatever based on the physics exist nowadays, but it is only amount available in the less quantity. But my point is, in the future, now people are researching or investing more and more money and bandwidth in terms of time and research to again align with this quantum electronics plus this industry 5.0. So in nutshell, we can say that the future is human centric. Second, this industry 5.0 is not about replacing humans with machines, but empowering humans with machines that are intelligent, efficient, and sustainable. And third, this now era of sensible silicon has arrived. So where AI fit in this fab? Process control, fault detection, yield optimization, equipment health monitoring. So we need to define our objective, and based on that, we need to work on this AI, how we can fit and how we can contribute. AI data source in the fab. AI use cases in semiconductor fabs. So these are all these use cases. Okay, now we are not touching upon this MCQs because here from this you can see many MCQs. So here, people are talking about this. Now let's session forum is open for question answer. So can anyone answer this without this using this chat GPT or mobile phone, because online, so I can't track whether you are searching on net or you are directly answer. Who is father of artificial intelligence?
B.
Now you can mute yourself and answer.
B.
B, yes, John McAfee. In which year? This AI recognized by this world in which year? Anyone, any answer? Or from this you can select A, B, C, D. It's not affected certificate, no worry.
C.
Participant, you can unmute your mic and answer.
Yeah, any guess? I love Gappi Das, no issue. I know a couple of faculty members having experience more than me, but I love Gappi Das.
C.
C, yes, over 65, because this coin raise is the 1956. So what is this term AI winter is used to describe? What is called this meaning of AI winter? So means journey started in 1956, and we highly adapted this after this 2010. So what happened? So some AI winter is there. So what is called AI winter? Quickly. No idea? Then it is your DIY. Do it yourself. Yes. Okay. No worry, because I have a couple of questions for you, but due to time, we are skipping those part. Here also, does AI science or technology? We can brainstorm on this during your session or with your students. Why AI popular today? And this all those stuff covered by Mr. Nilesh. So we are not go deep dive into this. Yeah. So session forum is open for question answer. If you have any question, then feel free to ask me. Any question?
Yes, participants, any question?
No one new question? It's strange, because that again industry demand, we need to again encourage our students, because as already I told you, in a design verification or RTL design or anywhere, if you are in industry, then your student has to ask the question. So that those are the skill set that we need to impart as an academician. For technical, the people have NPTEL, the people have Udemy, the people have hackathon, the people have workshops, the people have FDPs. But what is the role, our role as a teacher? So we need to inculcate those skills as well. Those are the hidden skills, but that is a highly demanded. So if you see that my profile, my BEC in 2008, there is no embedded system, there is no VLSI exist in my syllabus. My ME in communication, my PhD in robotics, and then image processing algorithms. So there is no alignment with this semiconductor, and still I am right now doing in this live project in the semiconductor field, and I deliver a couple of sessions in the Gujarat, outside Gujarat, even though NIT level as well as this IIT level. So which are the skill set that I'm having? Self-learning, discipline, attitude, critical thinking, passionate. Those skill sets required by industry. Otherwise, if you look any, suppose take any Verilog, suppose right now, if touch wood, it's not happen, but your means whatever faculty members who are present over here, your organization says that now from tomorrow you are jobless. What you think? What you do? Does your degree, whatever that you are, because there is no expiry on this degree, that is a very bad thing. But yeah, we can improve ourselves by attending such session. So yeah, if session is forum is open, we have this 7 minutes. I can cover this other topics as well, because 7:30 I will disappear, but up to this 9 minutes, if whatever question in your mind, feel free to ask. Yeah.
Patolia sir, Ashish Kumar has asked that is there any losses with AI?
Yeah, losses always that anything having this two stuff. So people again moving this adapting. So AI. So losses means right now, if you need this 10 people, then later on, then those who are not having that skill set of AI, they people always have to find the other job. Those is that is called loss. But those people having that skill set, that people having that knowledge, they people always make the money and make the good future. So loss is only that I can see in terms of, because there are advantage as well as, because, and here yes, it's good point. If here we have to think on this part as well. We are in the race of semiconductor, but so can you think, if your students not placed in the semiconductor field, then which are the other options and what is the plan B for that part? And also I raised one question, fabless company, which are these products? So what is your answer for that part? Yeah, so sorry for that. So Ashish Kumar, I hope you got my answer.
Sir, Ashish Kumar has written that yes, of course, he has given thanks to you.
Okay. Any other question
And
that you can see?
yes, sir, one more question from Ketan Patel.
Mhm.
That what is synthetic AI? Hello.
Hello.
Yeah, am I audible, sir?
Yeah, audible, audible.
Yes. 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 So Mr. Ketan Patel has asked that what is synthetic AI?
So synthetic AI, that again, where he again that again it refers to artificial intelligence system that work with synthetical generated data instead of addition of real world data. That is called synthetic AI. The trend tested or enhanced is using
Sir, just a minute.
artificial
Sir, just a minute.
data.
Dear participants,
Huh.
please turn off your mic. Dear participants, please turn off your mic.
So here synthetic means that mimics of real data, and synthetic data is not collected from real people or real machines. It's created using simulations, models, or AI, and it is designed to look and behave like real data. So that is called synthetic AI. So here difference in terms of synthetic data, because AI always need the data. So in a normal AI, we are collected data from the real people or real images. But in case of synthetic data, what happened? So suppose you are working on that, and AI fuel is data, and data is not available. Then how you can generate the data, or how you can generate the data set? So now people are adapting that approach, that is called synthetic data. So with help of simulations, with help of models, or with help of AI, we are generating data, and those data are called synthetic data. And we train our model based on that synthetic data. And after that, we tested and validate definitely our model on the real base. And then we are comparing, or we are saying accuracy. So based on that, it reduce dependency on real data. So suppose with help of synthetic data or AI, if your accuracy is 99%, then you are good, because without taking that real images, or suppose real data from the people or world, your simulation, your models, and your AI is a much powerful, those giving such data, and you are validate your model in the real world with help of real applications, and you are achieving accuracy 99% or more than that, or between 95 to 99, then it's always helpful to us. So that is called synthetic AI. I hope are you aligned with my answer, or if you have any query question, then please reply. Yeah, any other question?
Sir, Vinit Joshi has asked that Will
Mhm.
AI replace human engineers in the semiconductor
N-
industry,
No,
or will it
no, no,
mainly
no.
act as support tool?
So here, this AI is only that if you look at the AI is nothing but it's the prediction. So, but what is the difference in this AI base driven and that human base? So God gives that human having that judgment. So AI is only helpful us for repetitive tasks and to automate that automotive task. But we require human efforts definitely to judge that, because we not right now depend whatever answer given fully in the semiconductor by AI, because this AI semiconductor is a very costly field, because someone wants to manufacture or fabricate that uh, cheap, then here engineers are costly, tools are costly, fabrication costs are also costly. So directly or indirectly, AI never replace entire human efforts in the semiconductor field. That is for sure. Today, after 10 years, 20 years, or throughout. That is for sure. If we are alive in this planet, then we definitely meet again and verify. But right now, you have to trust my words. It is not never replaced due to couple of reasons. Yeah, 2 minutes only.
Sir, someone has asked that which is best open source tool for verification of AI driven SOC verify.
Yeah, so here that open source tool, first of all, the people are using this EDA playground. And for that AI, that CocoTB, people are developing that right now, Python based development for that developing of test bench. So Copilot, CocoTB, you can explore with help of your that Python. So UVM base also it is there. Otherwise, that proprietary, the people that synopsis and that kind mental graphics that integrated. But as a part of that open source, some research scholar or that dissertation also people are doing in that field with help of CocoTV. Yes, I hope everyone must align with my presentation, and that this should be informative and useful.
Definitely, sir.
And it's not
Definitely.
overlap with other experts session and the contents.
No, it's
That's
truly new, sir. Yeah.
yeah, yeah,
Yes.
yeah.
Dear participants, before going for the vote of thanks, I would like to request everyone to switch on, turn on your cameras to have a good photograph, to just build up a memory.
Meanwhile, uh, I highly associate with that this engineering sastra. So there are three layers I always that announce. That first layer is information layer. So that is what. If question asked with what, if you are able to answer, then that is information layer. Second layer is a knowledge layer. That question always asked with why. So if we are able to impart that what and why, then your students definitely have offer later. But third stage, third layer is very, very important. That is called applied knowledge layer. And I always stated that code to anyone. Okay, even though not us, but if whatever you believe in the God, if God teach you, and this third layer is not imparted by you, then you are useless in the planet. That is called applied knowledge. How, where, when. So whatever knowledge we have, and if we don't have the don't know how to use, where to use, when to use, then it's not totally useless. So during this my 4 years of journey in this industry, I saw that a couple of engines also fired, even though they have 90 percentage in the SSC, 90 percentage in the HSC, and secure this 9 point CGA more than the BTech as well. Even though we people fired those students, why? Because if we are asked question from what, yes, that we have answer. If we ask question from why, they are very good in the knowledge. But once we assign the problem statement, then at that moment, the people not able to perform within the timeline, or after that, suppose due to some reason, if such candidates, we always extend the timeline, but even though they are not up to the mark, then the people always fail. So applied knowledge layer also you need to please encourage your students. So that's why the people on only himself or herself can helpful to those part. Even though God not helpful in that part. Yeah, thank you, ma'am.
Thank you, Jignesh sir.
Yeah.
Hope you are doing well.
Thank you. Yeah, Charmi ma'am. My side over.
Yeah, thank you.
Hello.
Help. Yeah. So, ma'am, your voice is breaking.
Hmm.
Yeah, no worry. You can start your next session. Thank you, everyone, for question and invite me. Thank you, V.V.P. team entire. Thank you, Tolakia sir, Jignesh Joshi sir, Ravin sir, Charmi ma'am, Sneha ma'am.
Sir, I
Thank
think
you, Jignesh sir.
Thank you, sir.
We are
Yeah,
always
thank you, ma'am.
very
Thank yeah, Paras sir.
Will we get the PPT?
Yeah, definitely. Why not? Yeah,
Thank you so much.
Because
I will
while
provide.
you were taking the class, our concentration was more on the slides rather than on the asking questions.
Okay, no issue. Later on also you can connect with me if you have any question. I'm open to answer because by heart I'm teacher and teaching is my passion.
Thank you very much.
Yeah, thank you.
Yes.
Bye everyone. Bye.
Thank you
Have a
so
nice
much.
day. Yeah.
Sir. Hello, Charmi ma'am.
Yes, sir. Now I'm in.
Okay, ma'am.
Fine.
Everything okay from your side?
Yeah, everything is okay now.
Okay, ma'am.
So I would like to give a sincere thank to Dr. Jignesh Patolia, sir, for your insightful and thoughtful provoking session. Your valuable sharing of industry perspective on semiconductor technology and the role of AI in chip design and fabrication has truly enriched our understanding. The practical insights and real world experiences, as well as the future aspects you share with greatly benefit of all the participating faculty members. On behalf of V.V.P. Engineering College, our team, and all the participants, I extend our sincere gratitude to you for sparing your valuable time and contributing to the success of today's session. Once again, thank you very much, sir.
I think sir has left the session.
Yes.
Okay, ma'am.
So
We can move.
I hope Deepak Kausik has joined. Mr. Deepak Kausik, have you joined the unit?
Yes.
Oh, thank you very much. Thank you very much. So, participants, you please turn off your cameras. And now I would like to start the new session with Mr. Deepak Kaushik. Participants, turn off your cameras. Am I audible?
Yes, ma'am.
Yes. Yeah, participants, you please turn off your cameras. Turn off your camera so we can start our new session.
Okay, ma'am.
Thank you very much. Thank you very much, everyone. Deepak Kaushik sir, you please check your PPTs so we can start the session after inviting you.
Yeah, I think I can share my desktop and I can share my PPT, right?
Right now it is not visible.
Shall I share my screen and start sharing the PPT? Because
Yeah, sure. Sure, sir. Yeah, please try once again.
sorry,
You please try once, sir.
try sharing my screen and sharing the PPT, is it?
Yeah, yeah.
Okay, I'm sharing my screen.
Yes, it is visible now.
Okay,
Yes, it is
okay,
visible now.
okay,
So,
okay.
yes, yes. So let me start. Respected HOD sir, our esteemed speaker, and dear participants. It now gives me great pleasure to invite Mr. Deepak Kaushik to join this session for the online Atal Faculty Development Program. Let me introduce Deepak Kaushik sir. He has completed BTech in Electronics and Communication from VTU University in 2011. He has 14 plus years of hands-on experience in ASIC and SOC verification field. He worked for AI accelerator NOCs, memory controller, DDR3, DDR4, AXI, MIPI Unipro, DFI on protocol level. He has implemented V.V.P for Unipro MIPI. He is well versed with languages like Verilog, System Verilog, UVM, and C. Currently, he is working in Microsoft as a senior verification engineer level 2. Mr. Kaushik will be addressing us on the topic chip design flow from specs to code with AI, a highly relevant and timely theme that bridges traditional VLSI design methodologies with the emerging role of artificial intelligence. His insights into how AI is transforming the journey from design specifications to executable code with certainly provide valuable learning and practical perspective to all the participants. On behalf of V.V.P Engineering College and Atal team, I coordinately invite Mr. Deepak Kaushik to kindly take over the session. Sir, we are honored to have you with us.
Yeah. Thanks, Charmi ma'am. Thanks for that nice introduction. Yeah, let me start my PPTs. And please stop me whenever you have questions. Since I'm sharing my PPT, I will not be able to see who has raised your hands or who wants to ask a question. So please directly unmute yourself and please start ask question if anywhere if you feel that you have not understood the PPT. All right. The second thing is I have this 50 slides of PPT, but I was not aware that the functional layout and the manufacturing has been taken care, right? So I will just concentrate on to the specs to code with the help of the AI, how we are revolutionizing our front end verification, which I have the expertise with the AI, right? Let's start the journey with me. So this is my screen visible? All of you, can you see chip design flow from specs to code with AI presented by
Yes,
Deepak
sir.
Kaushik?
Yes,
Is
sir.
it
It is
visible?
absolutely
Okay.
visible.
Okay, okay. Let's start ahead. So what I will be doing in my 1.5 years of the agenda is we will be covering the chip complexity, which has been risen. Now, I think the chip complexity does not align with the Moore's law, the way the chip companies are coming with the new models, right? The schedule pressure which we are in to deliver to the market in every year. If you see a new AI accelerator, you have heard about NVIDIA, AMD's, Microsoft, Google's coming with the new hardwares, the new models like Gemini and Throp, right? In just 6 months to 1 year, right? So there is a huge schedule pressure on us, on any of the VLSI hardware engineers, to make sure that the chip works in the market as per the performance, right? So the schedule pressure is huge, the chip complexity is huge, and we will also understand how AI Copilot is helping us to beat that schedule pressure and chip complexity, right? We will also cover the digital flow part of it, that how specification is being made, right, from a right architecture. From that specification, how that architectures, the micro architecture gets developed, right? And from there, how an RTL gets developed, right? We will understand how it was done traditionally, and then we will understand how AI is helping us in all that steps, right? Then we will also understand how AI is working or helping us in the verification domain, right? If a chip verification is not done properly, it is sure that that chip will not work in the market, right? It is a very important aspect of VLSI, right? Until and unless the verification of that design, of whatever design it is, right? AI accelerator, you can take it. You can take it a very small AXI bus. You can take it, right? You can take an example of a mobile, right? If it's not verified at the simulation properly, it is sure it is doomed, right? It won't come to the market, and then company will lose billions of dollars, right? Because a wafer of a chip takes billions of dollars to get into a real model, right? If there is a bug in that, it's all gone, right? The money is gone. So there is a heavy front end investment into the chip fabrication. To make sure that investment goes right, it is very important that the verification of that RTL is very strong and very robust, right? So we will understand how that verification happened for the UVM, the formal, the coverage, right? How the debug part it happens, and how AI is assisting in our verification, right? Now there are two parts of verification. One is the analog and one is the digital, right? So to give you the perspective of a layman, right? If a fifth standard or a 10th standard or a college grad asks, sir, what is analog and what is digital, right? So the analog means how a clock gets generated, right? So digital, it is 0 to 1, 1 to 0, right? But analog, it doesn't happens that way, right? It slowly starts from the 0 voltage and then it reaches to the peak value, right? It is constant in the peak value. There is a leakage in the capacity, and that drags down, right? I think the students would be aware of the leakage, right, in the capacitor, right? That's how the memory also works, right? So that's the analog part of it, right? So nothing is a 0 to 1 or 1 to 0, right? So we need to make sure that that chip works in the real world also, right? So that part is covered in the analog and uh, I think, can all of you mute yourself? I think I can hear some noise.
ఒంగోలు పిల్లని ఉంటారు నీ కాదా ఒంగోలు పిల్లని ఉంటారు నీ కాదా ఒంగోలు
Participant, please mute your mic. Participants, please mute your mic.
Hello.
Dear participants, please mute your mic.
Just a minute, I take care of this delegate. Hello, hello.
Yeah, I think I have muted Mr. Sherukuri Rajni from my side. I think that is fine now. I don't hear any more noise. Shall I go ahead? Any questions till now? I see one hands up, Umang Patel. Yeah, Umang, do you have any questions?
No, Deepak, I guess they should continue. We'll take care of the question.
Okay. Okay, fine. So, yeah, so the analog part of it is also a very strong and very important part of the verification, right? The analog mixed mode planning, right? How the clock in the analog domain gets into the digital domain, right? The voltage, basically the voltage fluctuations. That's why we have ADC and DAC converters, right? Which converts the analog to the digital, right? When it crosses the analog boundary to the digital boundary. And then we have DAC converters, right? Which converts from the digital to the analog boundaries, right? So we have these two converters, but then there is a whole new domain of analog. So if any students they are exploring anything in the VLSI, so there is one digital domain which we can get into. There is one analog domain which we can get into, right? There is one digital domain if you are very good with the Verilog or the VHDL coding, right? So you can get into this RTL domain. Then there is one more aspect of the chip fabrication or the coding, right? Which is the emulation, the validation, and the low power verification, right? And we will also talk about how the AI assist in this, right? So low power is basically nothing but if you would have seen mobile, right? If somebody complains my battery drains in 10 hours or my battery gets drained into 12 hours, right? It is because of the heaviness of that particular architecture, right? So the architecture which takes more power, the battery would be drained more increasingly, continuously, or more profusely. And if the design is low power, right, means it takes very less power, then the life of the battery remains, right? So we need to be sure that if we are architecting it in a way where we will be using in a model where it uses a low power, we need to make sure that the architecture also takes very less consume very less energy, right? So that the power of the battery elongates, right? And then the emulation and the validation part of it. This is not exactly the front end, but then it falls into the front end and back end. So it's a bridge between the front end and the back end verification, right? So I would be covering this. And then we can take some case studies, the guardrails and the risk, which AI comes, right? There are pros and cons for each artificial intelligence. And then question answers if anybody have any question and answers, right? Okay, so now what is the motivation of this particular session, right? So the motivation of this particular session is why we need AI's help in our chip design, right? And why we need it very urgently, right? So if you see the design size of it, right? So I'm not sure if anybody you would have seen any chip onto that, but if you see the power of that chip or the features of that chips are getting increased day by day, right? If you see now there are 50 megapixels of camera, 60 megapixels of camera. There are dual core processors and all that, right? But then the mobile size is very small, right? Because the complexity of the design, how they are manufacturing, right? They, it is increasing rapidly, right? And if we need to make sure that the power domains of it, the interfaces and the IPs which we are using needs to be make sure that the design size is less, right? If the design size increases, the IPs, the interfaces, the power domains all are increasing, right? In our day-to-day life, right? So how AI can help into us is AI can let us know, okay, this design size, let's suppose it is in nanometers, right? If you know TSMC company, which is in Taiwan, right? That is the major company which manufacture anybody's chips, right? All the mega captex, the Nvidias, Microsoft, AMDs, right? Right. So the wafer is been fabricated in a 2 nanometer, means it's less than a single thread of hair which we see, right? So in that billions of transistors are there, right? Now how those billions of transistor gets converted, right? From your design to the flops, right? Those that converter, right? So the more efficient the design is, right, the less transistors, right? So AI help us in the design size and the integration of it, right? So that's the RTL part of it. Now comes the verification, right? Now to verify this design, the size of the verification test benches which we build are also getting increasing day by day, right? Huge complex test benches, 1,000 codes offline, right? Now, if I am a senior verification engineer, I can understand in 1 month, right? Now, if a new grad from college comes in, it will take probably 5 to 6 months for him to understand for that candidate, right? So now what we can do is we can ask AI, right, to help us in what is the verification data flow of our verification test benches, right? So AI can help in that, right? Now there are failures into the verification test bench, right? If you write test cases, there are bound to be failures, right? How to debug that, right? Because debugs also takes lots and lot of time. So we can ask AI to help in our debug, right? So what is the data flow, right? We can, so basically we can make an agent of our AI and we can train that agent in our way, right? I can take a different session how an AI agent is made. That's a different thing, but we can train that agent that this should be the way how you can tackle my code, right? If you would remember, there are companies like Google, Microsoft, big companies. So we have integrated AI onto our Windows and to in our Linux system also, right? So what we do is if we want anything which is from the web, we use our Windows Copilot, and our code, right, which resides in our Linux open area, we can directly use that also, right? So companies are also helping the engineers to make sure that we leverage AI in our day-to-day work, right? Before that, there was a huge demand of script engineers, data engineers, right? Now AI has taken all of that jobs. Why? Because now if we ask AI, AI, can you make me a script to present the slide of 50 decks, right? It gives in 2 minutes, right? You won't believe it. This side, which I'm explaining to you guys, is been implemented by AI. I have not even written a single PPT of this slide, right? It's all AI. If you see, the background is AI, the context is AI, everything is AI. I have not written, and it took me only 2 hours, right? Now, if you see that particular thing, when I was in college 10 15 years back, it used to take me months to create a slide of 50 decks, right? Which can impress my HODs and we can get marks out of it, right? But now AI does it in 5 minutes, right? If you give it right, uh, if you give it a right input, right? If you give it a right a thing which it needs to create, it can do in less than 5 to 10 minutes, right? So months of work is being converted to only 10 minutes of thing, right? So it is very important how we train our AI, how we give inputs to our AI so that it can give a relatable output, right? Now the third point is where AI can help us. So if you remember this verification and the design, it cannot be on the open hardware, right? Anybody cannot do it, right? So there are three companies in this world, Synopsys, Cadence, and Siemens. Those give some tools, right? On those tools we run the simulation, right? And if you see the license of those tools, those are very expensive license, right? Like colleges and universities, they cannot say that for 500 students we need to have 500 licenses. It's very it's in lakhs, right? Basically, so the EDA runs are expensive, right? So if the EDA tools are so expensive, how we can reduce that cost, right? We need to make sure that the verification in the design iteratives, what happens onto that EDA runs becomes less, right? So AI can also help in those particular things, right? That the EDA iteration becomes less. The less iteration that the EDA tools can be used among multiple students, and then multiple students can get benefited, right? And then this is the mixed signal and the low power, right? Mixed signals, I said before that the analog mixed mode signals are there, and there is a low power complexity, right? So AI can tell us, right, that this particular component is taking more power than your estimated power management, right? So we can optimize that particular block, right? And then we can make sure that it takes that much power which is getting intended, right? So AI can help us into it, right? So as an whole, AI can help in the repetitive work, right? Which it can take days, right? But if you give it to AI can do it in minutes, right? And then you can concentrate on the critical work which you have, right? It can summarize very easily, right? It can search anything which you want. You do not need to Google each and everything, and it can automate now almost every thing, right? So this is the power of AI, that if we use that AI in a very efficient way, optimized way, it can give us great results in all of this, right? So this is the motivation for this particular thing, right? Now this is end-to-end chip design flows. I just wanted you guys to know that what is the end-to-end chip design flow, right? So how it happens and how it gets tape out. So spec is basically like somebody, if some person has some plan, right? Let I want to build an aeroplane, or I want to build an AI accelerator, right? Or I want to build a next gen car, which is fully automatic, right? So that person comes with an idea, right? Now that idea he needs to jot down in some paper, right? What will be the thing, what needs to happen, right? So basically that becomes a raw specification, right? That I need a car with 4 tires, or let's suppose 6 tires, right? Or 4 windows, or whatever windows we need, right? 2 seaters, 4 seaters. So that becomes a very 30,000 feet level of a spec, right? Now that spec goes to a person which actually have knowledge into the manufacturing of cars, right? He can say, okay, this is doable, this is not doable, we need this much uh, money, we need this much time is it's needed to get to the market and all that, right? So all these things are needed, right? So that person will then convert the spec into the architecture, right? So this architecture will define how a car will be made, right? Now we have a good architecture, right? Now from that architecture a design will be made, right? That how this should work, right? When that comes into the wafers, right? When that chip is actually made, right? Basically, right? Like if you would have remember in when COVID happens, there were some chips in the Tata car which were having very short means which were not there in the market, right? Because the chip manufacturing unit was closed, right? So if you see any automobiles or any mobiles for that purpose, they have chips inside it. If that chip is not there into the market, the car production, the mobile production, anything, if you see the chips are there now in the washing machine also, in refrigerator also, right? If that production goes low, I think now almost 80% of the consumer electronics uses that chips, right? So they will also not be in the market. So that is the importance of a good chip, and that good chip, when it comes to the market, the backend process is the RTL and the verification of it, right? So then the verification of that particular design happens, right? So when that happens, it goes to the synthesis. Synthesis is the PD flow, right? Where each flip flop will be sitting, where each capacitor will be sitting, right? That happens in the PNR. So the full form of PNR is place and route, right? In a chip where everything will be sitting. Then that happens a sign off, right? That there is no electronic induced magnet in that flow. The current is not leaking, right? Everything is fine. So that happens on the sign off. And then happens the tape out. So when we say the tape out, so basically, if you would have any second or third year students would have seen, right, that there is an PMOS, NMOS, and then the drill happens for that thing. So that is basically the wafer coming out, right? So that is basically called a tape out, right? So my expertise lies onto the verification part of domain, which is called front end domain, right? Right now we will see where the AI adds value, right? So the AI adds value in the spec parsing, right? Now what is spec parsing? So if somebody comes up with a spec saying that we need this particular spec in this way, right? I can invest 10 days of my thing writing that spec, right? But if I tell AI that please implement a spec, I do this list of thing, right? And make it a very crisp or complex, right? Then that spec is been implemented by the AI, like this PPT, which was implemented by the AI in 10 minutes. The spec can be implemented by the AI in less than a day, right? Now, what you see, you just go through it and you can give a feedback that this is missing or I need an enhancement in this, right? And it will make sure that the spec is been written in this way, right? The moment you start talking with an AI agent, he understands you, right? And then he will always make sure that this was that feedback which you would have given, right? So any other things which he starts implementing, he knows that this is what your requirement was. So based on that requirement, that spec happens, and then the block diagrams are. You don't need to now write block diagrams or need to take a photo and then click on it, right? No, you just ask the AI co-pilot agent to make block diagrams of this things, and he will do all these things for you. So it's a massive help for the architectures, right? Because now they can literally think of what all the critical things they need, right? They do not have that overhead or the headache to write things which will take 10 days of their schedule, right? It just tell this the way, and then AI will make it happen, right? Now comes the important part. Now, previously, the designers were hired by the companies to make sure that the coding of the RTL happens true, right? Because if the RTL is bad, if you do a thorough verification also, still the chip will be bad because the RTL was not done properly, right? But now those engineers are taking help of the AI to make sure that the RTL is very robust, right? So what they do is they feed this spec, right, into the AI, and then tell that AI that, okay, in this Verilog code or in this VSDL code, you implement an RTL for me, right? So a skeleton of an RTL, the whole things of an RTL come within 5 to 10 minutes, right? You do not need to invest 1 week of those to get comes. You just need to give a feedback to the AI that, okay, now this RTL are missing these things, right? Like if you need a parameterized RTL, right? Or if you need a width of that RTL, which is not as per the logic, right? The AI will do it for you, right? So now that's a very less headache, right? So it is like telling your junior to do the work, right? Now, instead of junior, it is not a junior, but it's an AI, right? The scripts, right? If you want to have any automated script like Perl, Tickle, Python, right? AI can do it in just seconds for you. It's very easy, right? And let's suppose if a company asks you that you already have a code. Let's suppose a USB thing is there, right? Now the market is coming with the USB 4 specification, and the code has the USB 3. You can just ask the AI that this is the USB 4 specification. I have this RTL, right? You give that RTL as an input to that particular AI. You give an input of the USB 4 spec and tell that whatever is remaining, whatever is the difference between a USB 4 and USB 3, just make sure that you implement that into the RTL, right? And then AI will do that. You just need to make sure that whatever the AI has been AI coded RTL is fine as per your expectations, right? So it really help us in the way where we are doing things, right? Now, this is how it happens for the RTL. This is how we do it for the our verification, right? A verification basically happens for the language if you know system verilog, if you know UVM methodology, right? If you understand C, if you understand C++, right? You can be into that verification engineers thing. And as of now, UVM stands for Universal Verification Methodology. So this is the standard language which is used across industry to verify any design as of now, right? So this is the latest and the greatest, right? So as people implement RTL, that's the same way people implement the UVM test bench, right? So same way we can ask AI to help us, right? Now, after the verification happens, there are two more things which is very important to us. That is called validation and emulation, right? So verification happens in the simulator. The validation and the emulation happens inside the lab, right? Now let's suppose you have a chip which is been taped out, or there is a hardware of it, right? So you can bring it up into your lab, right? Before making it sure that it goes to the market, you can just bring up that wafer and you can boot it up, right? You can make sure that the PCI bus, the AXI bus, everything is working, right, before it goes to the market. So there is this one step where if there any bug which got escaped from the verification can be catch hold in this validation and can be debugged, right? So at this point of time, obviously the time to debug and fix it is very high, but still we will not lose billions and millions into it, right? We can still debug it and fix it in the RTL and then just retape out it, right? So validation, and then comes the emulation. So emulation happens into a system where we particularly mimic a system, right? So in that also we can ask AI to help us with the step to decode the instruction, right? To decode what is happening. So basically a combination of software and hardware is the emulation part of it, right? So if we want to write any software in C and C++, right? We can ask AI that I need this particular code. Please code it for me in C, C++. He will code it, that AI agent, and just you need to make sure that that coding is as per your expectations, right? You need to uh, uh, do these steps 2 to 3 times, but instead of wasting 3 4 days into it, it can be done within a day, right? So now that validation emulation also can be helped in our AI, right? And then if any bugs are found in validation, we do the ECOs, right? We do the DRCs towards the closures, right? And then there are some reviews with the formal team, the golden matrices. We need to make sure that the chip is good to be vaporized by a wafer company, right? So in all these things, I explained how AI adds value over here, right? So let now I will deep dive into how a good spec is made, right? So before going into deep diving the front end verification code, are there any general questions for me or any curiosity, anything which anybody wants to ask? Okay. Okay, that's okay. I will move forward. At the end of the presentation, we will have question and answer sessions. We can take that at that time also. So that's fine.
Yes,
So
sir.
now
That would be
when,
better.
okay, okay. Yeah, thanks. Okay, so now what a good spec look at, right? So a specification should have all these features, right? That what should be the functional requirement. So if you're making a chip for a mobile, if you are making a chip for a server, if you're making a chip for an automobile, right? You need to tell what are the functional requirement for that particular spec, right? So if you want to say about the features, if you want to say about the modes, if there is some error, how a chip will handle that error, right? You can just feed it into the AI, and then AI can write those things into your specifications, right? Then what is the latency of that chip? What is the performance of that chip? Now, like billions of things are working in parallel, right? That is the major difference between a GPU and the CPU, right? CPU doesn't do parallel things and GPU does parallel things. Now, billions of things are happening in parallel, right? So what is the latency of those things? What is the bandwidth of those things, right? You can ask it to the AI before picking it into the spec, right? So that what is the throughput of that particular chip, right? You just throw some formulas to the AI, then AI will come up with the answers to that, and then AI will understand your need also, so of what complexity you need, and based on that, since AI is trained onto the millions of data which has been there, right? Like NVIDIA is launching chips on chips, AMD is launching chips on chips, right? So basically AI understands each and everything. We just need to throw the formulas and it will give the answers. If we don't know the formula also, we can ask AI that I want this particular thing. What should be the formula with the best performance latency? And then AI will give it to you, right? So before even writing a code before writing an RTL code also, you will get to know many more things via the AI, which was not possible earlier, right? Because there was no, or you should have a PhD in that specific area if you need to know that things, right? But now you have a PhD holder sitting with you, right? In the which is called an AI, right? So he understands, or the AI agent understands that thing, right? So you can through post these formulas, and then you can come up with the answers, right? Now that functional requirement, which all interfaces, like let's suppose if you are having a memory chip, right? So the interface for that memory is different. If you are working on a memory controller, the interface for the memory controller is different, right? If you are working on an AXI accelerator, the AI accelerator architecture is completely different, right? It is a very new architecture, right? So what all interfaces should be used? Whether we should use PCI, whether we should use AXI, whether AHB is used, whether APP is used, right? Uh, AI can tell you each and everything in just minutes, right? What all things you used, and based on that, you can refine your spec, right? And what is NOC? NOC is network on chip, right? So what network on chip means? So basically, before, I would say 5 years back, right? The chip was different and the memory was different, right? You wouldn't have SoCs, right? What you had in mobiles. So the SoC thing was the revolution in the mobile which came, right? And that's how the mobile got revolutionized. Because in mobile you started getting having memory. Now, if you have a memory, you can store things into the mobile, right? Before that, things when it was Nokia 1100 or your black and white, there was no memory, right? There was no SoC. So now what happened? The designers or the architect, they thought that if you want to have a powerful chip, you need to have a big memory into it, right? Now that memory came inside the chip only, right? Now the bridge between the functionality of a CPU to talk to the memory, right? It happens between the NOC, right? So NOC is the interface where you speak between a CPU or GPU to the memory, right? So a NOC interface or architecture was implemented into the SoC itself, right? And then we have the IO ports, right? What is the input, output, the padding mechanism, right? So AI can help you in implementing all of this. If you tell that what is your need, you just need to tell that in a very simple English, what is your need, right? And as per the AI capability, it will throw you the solution. So whatever solution works best for you, you can go ahead with that, right? So that is how much easy and has AI has done things for us, right? Now there are constraints for us, right? That what is the safety or what is the security, right? Like if you would have seen, right, there is a cyber theft of it, right? So you can ask AI how you can provide uh, a hack onto that hardware, right? So that that hardware doesn't get hacked via software or the hardware, right? So hardware doesn't work by itself. So on hardware, there is a top layer of called as software, right? So if a person hacks the software, the hardware automatically gets hacked, right? Because the commands comes from the software itself, right? So you can ask AI how to make robust your software and hardware so that it doesn't get hacked, right? So that all things should be a part of a spec, right? And then the deliverables, that what should be the acceptance criteria, like let's suppose the bandwidth should not be more than 100 Gbps, right? Let's suppose, because it's a low power, that particular, let's assume that SoC wants to get into the mobile. So how that mobile should not consume more data, right? So for that, you need to limit the speed, right? That it should not go beyond 100 Gbps, right? So you can tell the AI that I want a feature whose uh, bandwidth should not increase 100 Gbps, right? And it should take less memory. So it will tell you the solutions, it will tell you the options of how a spec can be made, right? Because it has been feed through the billions of data when it came into the market, right? So that's what model are. So ChatGPT 1, ChatGPT 2, 3, 4, 5. So what are the incremental models is they get trained more enough by the billions of data. So the more data it has, the more intelligent the AI becomes, right? So if you have all these things into a spec, we can say that is a very, very good spec, because it has all these functional things, non-functional target interfaces, constraints, and deliverables, right? Now, when we have a good spec, right, we just need to turn that spec into an architecture, right? And how AI helps into it. Now, since we have implemented a spec, we can give that spec as an input to the AI, saying that now we need an architecture. So what is the difference between a spec and an architecture, right? So spec is a document, right? But then architecture is that how, where the NOC will be implemented, where the interconnect will come, where the memory will come. It will say, okay, memory should be on the right hand side or on the left hand side of the CPU, right? So that all comes into the architecture. So architecture is still into the papers, but then it is a diagram, it is a block diagram, or it is a set of diagram which will make sure that how that SoC looks, right? Where the bus will be there, where the CPU will sit, where the GPU will be sit, how many lines of pipelining will be there in the CPUs, how much CPUs you need for at those designs, how much GPUs you need, how much terabytes of memory you use, whether you will use a HBM memory, whether you use a DDR memory. So the full form DDR memory is double data rate. The full form of HBM is high bandwidth memory, right? Or is it that the NAND memory can also be sufficed, right? So the more memory, the bigger the chip will be, right? Because then it will take more surface area to sit into it, right? So all those things comes as a part of architecture. So the specification says that I need a memory. That's it. But the architecture will define what type of memory you need and how much huge memory you need, right? So, or it can happen that you can, so let's suppose one architecture will say you can have 1 TB of memory, right? But then other architecture will tell that you need 4 chunks of memory of 250 GB. Though the width of the memory or the depth of the memory is 1 TB, but then it is up to the architecture that you need one full memory of 1 TB, or you can have 4 different memories wherever it is sitting, right? To make sure that the throughput and the bandwidth which you want to achieve gets achieved, right? So in all that case, an AI can help you, right? By feeding all this information into the AI, right? So AI can come up with the answers that it supposes that a full memory of 1 TB is more beneficial for us rather than 4 chunks of memory, right? So it can help us in our understanding, right? Or it can also give us the data why it thinks that 1 TB of memory of 1 chunk is enough instead of 4 chunks of memory, right? So all those things are, we can ask AI and then AI can help us into it, right? Then comes the control, the arbitration, the error path, the QoS. So QoS is nothing but the quality of service. So what does the control or the arbitration uh, means, right? Let's suppose we have given the command to the chip that click a photo, right? So now we have just pressed it on the software level, right? But how does it go into the hardware, right? So there are many layers of it which transport that part, and then it at the final it goes to the hardware. Now it can happen that any of these layers which are on top of hardware goes wrong, right? Or it is not able to accept the data, right? So that you need to make sure that if that happens, how the chip will react, right? Is there anything which we can recover from it, right? Normally we say if the mobile phone gets hanged, you just give a restart, right? Then the booting will happen. So this is one of the mechanism for the hardware, right? So that it comes up or copes up with that error path, right? Then the arbitration happens, right? If you need a 50 megapixel camera or a 20 megapixel of camera, so how does the quality images get adjusted into a mobile? For English, it is very simple, right? But the complexity lies into the pixels, right? You need to be master of the pixel format, right? That what a 20 megapixel mean or 50 megapixels, right? So but the formula to it, you can ask AI and then AI can give you an RTL code that, okay, these are the things which can happen, right? So all these things which comes into an architecture, right? So if you need a 50 megapixel camera, how much depth of memory should be, or how much megapixel it should be, or what is the data mechanism to flow into that. So all these things are taken care into the control, right? And obviously we can ask AI of what it needs to have and what it needs to happen, right? And then the interfaces. So what interfaces means is where the IO will sit, right? Now let's suppose if there are two AXIs, or we need 3 ports or 4 ports of AXI, right? How that AXI ports will come into the picture, whether do you need 4 ports or 3 ports or 2 ports, right? Architecture is an intelligent guy, but if it has a junior or a colleague who can help him to make sure that, okay, this is the best thing, it's an AI, right? He can just ask AI that what then AI thinks should be that done, and if it matches him expectation, he doesn't need any other validations, right? Now people are working cross geography, right? I am in India, I'm working with the US, so there is some time lapses over there also. But if you have an AI, you do not need to be dependent on any other colleague or your manager to make sure what is the right decision, right? So if you are if the AI gives as per your expectations, you can go ahead, right? And then what is the reuse and the new IP that into the architecture, like AXI is a standard protocol, right? We get IPs from many of the vendors, right? So architecture tells if you need an AXI VIP or you need a custom interface, which is very custom to uh, your company, right? I will give you an example that if you take ChatGPT, so ChatGPT is not open source; it's a closed source, right? So what it means is that only the developers of the ChatGPT can reuse that or can modify that, nobody else, right? But if you see, China is coming with the open source model. So what open source means is they give hooks for the other developers also to have an incremental change on those particular code, right? So this is what it means, right? So in your architecture, do you need any open source platforms? Do you need closed source platforms? So you can ask AI what is best for our architecture, and then it can come up with the strategy, right? So this is how the specs gets converted into the architecture, right? Now an architecture has been done, right? Now comes the design engineers, right? Who understands Verilog, the VSDL and all parts, right? Now that architecture needs to get converted into the micro architecture, right? Which will be feeded into the design part of it, right? So let how many FIFOs it want, right? Now let's suppose if controller is there, it is let me give an example, real time example, that AXI is 256 bytes, right? But there on the other side, when it is talking to the memory is only 64 bytes, right? So and the let's suppose the clock speed is 2 gigahertz, right? Onto the memory, it is also 2 gigahertz. Now, if you see, the controller is taking lot of data. At one clock, it is taking 256, right? But the memory is only allowed to take 64 bytes as per its interface, right? But then you need to save that much data into the controller, right? Now, who will tell what amount of data needs to get settled? What should be the depth of the FIFO? What should be the depth of the pipeline? So then there comes the RTL design engineer, right, which writes the micro architecture. So any of the college grads who are interested or who are good into Verilog and all that can get into this jobs of the micro architecture guys, right? RTL. So these are the guys which write the micro architecture. Now these guys can ask questions to the AI based on their understanding, right? That if let's suppose if the AXI speed is 256 bytes and then the speed of the memory is only 64 bytes. So tell me AI, how much, what should be the depth of the FIFO which I'm building, right? AI can give you an easy answers. Before that, there would be a lot of calculations. Like there are many more permutation and combinations, right? That if clock frequency is 2 gigahertz and the read is only 1.6, or the write is less and the read is more. So based on all those permutation combinations, if you feed this into AI, you will get to know what is the depth of the FIFO you want, right? Now there are credit schemes also, right? To make sure that the data is not dropped, right? You have credit schemes, right? Let's suppose if a host and a target are communicating. So how does the host know that the target is ready to take my command, right? So there are two ways, whether there is a ready valid handshake between those, right? Or it's a credit based handshake, right? So many protocols work on the ready based handshake, many protocols works on the credit based handshake, right? So based on that scheme, how your micro architecture, you can feed and ask the AI what type of scheme you want, right? Then the AI can tell you, okay, for this particular micro architecture, this particular scheme would be better, right? So your answers are there and there. You do not need to dig into the internets for hours, or you don't need to do many trial and error methods, right? There are reorder rules. Reorder rules means if somehow there is a reset in between, right, and the packet is there, how it will be transformated. Or sometimes if a packet reaches to the host but there is no acknowledgement from the host, right? So what does the host do, right? Will it wait, or is there a timeout mechanism? So all those things comes into the micro architectures, right? The FSMs are there, right? Final state machines, that okay, this is how it will be a normal state. If there is an error, what FSM should be followed, right? CSR means if you want to write any register, right? So how a hardware works, right? So there are configuration registers and status register inside the hardware only, right? So if you give command from the software will write into the registers, and then registers will give command to the hardware that you need to work in this way, and that's how the FSM starts working, right? Now suppose the FSM comes to a place, says that I am done, right? So what it will do, it will write to the status registers, and then software can poll onto the software registers, uh, and then the software can know, okay, now these things are done, right? So this is how the FSMs, the RTL works, right? So the RTL designer can directly tell to AI that I need this FSM, this is registers. You just write me an FSM thing, right? So in this case, if like the average designer, the difference between an average designer and a highly intelligent designer will go away. This is the purpose of AI, right? If you know how to control an AI, right? So if you are a 50% student, you are a 90% student, it is up to you that if you use AI very good in a very optimal way, you can easily beat a 90% student. That is my opinion, because you have a very good colleague which is always there to help you out, right? It has no emotions, nothing. It will tell you what it is, but you need to know what the practically aspect of it. So over here, if a person knows how practically the thing works, he will obviously excel in these areas of coding, right? Because he knows what should be done. He is average in any of the coding, but he can take help of the AI, right? That if I want this, you code me this, and AI is there to help you out, right? So the difference between an average or a highly intelligent person will definitely go away if that person knows how an AI works, right? So this is in the corporate world how it is looking, and it is evolving very fast, right? Tomorrow it can happen that 10 engineers which were needed to build an RTL, or now only 2 engineers are needed because AI can do the rest 8 of the work, right? So it is evolving very fast. So the more you get hold of the AI, the more your value in the corporate will be, right? In terms of if you take a software industry also, if you take hardware industry also, right? So in hardware industry also 50% is coding, right? So yeah, you need to have a hold on this AIs, right? And then there is our clock and reset domain, right? So let's that's what I said, right? AXI works in a different clock domain. Memory is working in a different domain. PCI has a different clock domain, right? Because the speed of the clock is different, right? So there will be different dividers and multipliers, right? So how many clock domains you have to make sure that there is no deadlock in between the clocks, right? So each and everything, a microarchitecture, if he feeds an input his requirement, right? You then AI can help you out with whatever seems best with your thing, right? Then there are power states, right? So basically you can tell, so suppose there are no communication between host and target, right? So in that case your system will boot down itself, right? And then there will be no power usage, right? If you would have seen your laptop also, so if you don't use your laptop or the mouse doesn't get flicked, the CPU itself resets, right? It sleeps, right? So it sleeps means it is taking very low power, right? So how this is coded into the hardware, right? Those are the things which microarchitecture do, right? So now you can ask AI what needs to be done, and it is there to help you out, right? And then these are very specific to microarchitecture, that we need assertions to tell, okay, this is a fail path or this is an error. You say you short for an assertions, right, into the simulations, right? There is our coverage also to make sure that the DUT is getting covered properly from the verification, and there are debug counters also, right? So these are very technicals to the microarchitecture. This when you come into this industry, have 2 4 years of experience, you will understand that what all this is. From now, from a grad point of view, if you're in college, this is fine, but still you need to understand this, that how an RTL designer works, like how he thinks. The more you think in a practical way, the more it will be better for you cracking any interview, right? So this is how the macro architecture get plans, right? Now in that microarchitecture, you need to have the transaction semantics, means the interface, right? Like how many AXI you want, what should be the ordering protocol of those AXI, right? What is the flow control, whether you need valid ready or credits, which I explained before, right? What are the error model timeout things, right? Which I explained before. So all these things is a part of interface, which is a part of the micro architecture, right? So all these things makes a very good micro architecture, right? Now when you have written a micro architecture, then the coding begins, right? Now the perfect the coding, the more you will mimic what an actual architecture wants, right? Now, let's suppose if you have a very good micro architecture, but then the coding is not that good, it will not have the 100% effect of the powerful architecture of or a powerful micro architecture should have, right? So the RK, and then this is an RTL. So what does it say is, let's suppose if you're coding for USB 2, now every 2-3 generations, USB comes up with a new thread, right? USB-C or USB-B, or the speed of the USB changes. You can take Wi-Fi, you can take Ethernet protocols. So your RTL should be scalable enough. So when you say scalable means if you're coding it for USB 2 or DDR2 or HBM, it should be scalable that when a new feature or a new architecture comes up for DDR3 or USB 3, right? Your present RTL should be capable enough to intake all those changes, right? And then embedded it to itself, right? Because before breaking it, or you should not write a new whole RTL when the coding changes, right? Because for the USB 2, let's suppose if you have taken an USB is universal single bus, right? The USB port which you have in laptops or in TVs, right? Those are called the USB ports, right? So basically, if you are writing an RTL for that USB port 2, let's suppose after 2 years USB 3. So it should not be the case you are writing a whole new RTL for the USB 3, right? Because it will take that much amount of time for USB 3 also. So whatever the RTL you have written for USB 2 should be good enough to align with USB 3 plus whatever the extra features have come into the USB 3 that should be imparted or embedded into the RTL itself, right? That is called the scalable RTL, right? So to have all those things, you need to make sure that your RTL should be parameterized, right? You should know what should be the widths, the depths, right, of the FIFOs, the pipelines. So what are, and you should have a very clear task, very clear functions, how the functions are divided, right? To make sure that, let's suppose if in a USB 2 it says that a clock needs to speak or a target needs to speak to a host in this 2.5 gigahertz of frequency, right? For USB 3 it can be 5 gigahertz of frequency, right? So if you write it in a generic way that whatever the frequency comes from the function, it gets divided into that part. So that becomes a generic solutions, right? Because now from the function, if you say 2.5, it will work in 2.5. Now, if a function you pass as 5, right, it will work with 5 gigahertz of frequency, right? So if your RTL is scalable enough, right, then you are set to be a good RTL designer, right? So this is how the RTL designer works, right? So he should know uh, how a designer is scaled, right? How a design is scaled. Now, where the AI part comes into it, you don't know how to write that generic formula, right? Let's suppose you are very new to the industry, you don't know, right? Or I will give you two examples where you are very experienced also, right? So you can ask AI that I want such and such scalable thing, which is should be very parameterized, and AI can give it to you in within minutes, right? You can review it, you can do a trial and error. If it comes to your expectations, fine, good, yeah, you are good to go, right? But those things should be in your mind, right? AI will not tell you that you want a scalable thing or you need to feed AI that this is what you want, right? AI can work on that, right? And it can give you ideas back. But what is best suited for you, ultimate user is the end user only, right? The person who is writing the code. AI can help you, but it's not that AI is 100% perfect and you just need to sit and relax, right? But you need to help AI to help yourself, right? So you need to give practical examples, and this is how the AI will come into it, right? So the parameterization should be clean. You should have clear responsibilities like what should be the FSM, what should be the pipeline depth, right? What should be the throughput, the latencies, and all that, right? These are very technical words that packed struck for transactions. So if you would have done system verilog or verilog or VSDL, you would have come across, or C also, you would have come across these terms, right? Structures and all those, right? Pointers and all those, right? So you should have a very good hold on to those to make a very scalable RTL, right? So if your coding is good, if your coding is good, your implementation is good, your architecture is good, you have done 60% good job, right? Rest 40% is on to the verification, the validation, the emulation and then the tape out, right? So till now, if you're good, you have made a good job till 60% of the things, right? Then now this we told as an assistant. Now what I told, right? How AI can help into is we just give precise prompts, right? So what prompts means as an input, what you give to the AI, right? AI understands and then it comes out with whatever the code it is, right? So how it comes with the code, it will give you the intent, right? It will also give you the corner cases scenarios which needs to be tested, right? It will give a skeleton, right, of a module, right? And then you will say how can you can populate it, right? It can also add logic incrementally, right? As I said before, AI can do that. AI can build skeleton also. AI can make sure that your RTL is lint clean, compile clean, right? So these are very technical words when you come into this industry, right? So there is system verilog assertions, right? It can implement those for you. You just need to give an English statement what you want, and then AI can build it for you, right? And then AI can also give you reviews and test cases for those particular RTL feature, right? So this is how AI help us in building the RTL designers. It's a very starting early stage, right? But then the power of the AI is huge, right? You just need to know how that AI gets built, and then you're good to go, right? So now we have ended the part of the RTL, right, of our end-to-end flow. Now we are entering to the verification, right? This verification, I am the expert of the verification, right? So this is what we work. So this is my domain basically, right? So now early verification, what early verification looks like. So basically there are two parts of verification. One is functional verification and the other is formal verification, right? Which has been introduced by the companies like Siemens, Cadence and Synopsys, right? So you need to make sure that the guy which have designed this RTL does not have any bugs, right? This is the responsibility of a verification. If it contains any bugs, your verification should be robust enough to make sure that there are no bugs into the RTL, right? So if your RTL is not good, your verification should be good enough to make sure that the RTL becomes good, right? And the norm of the industry is for one verification, for one RTL engineers, there should be 3 to 4 verification engineers, because verification engineer has more complexity in the test bench than the RTL engineers. I will tell you the reason why. The verification engineers need to understand the architecture, the MAS, the RTL to implement its UVM test bench or the verification test bench, right? Until and unless the verification engineer doesn't know these three aspects, he cannot uh, implement its test bench, right? Designer can designer does not understand verification, right? But verification needs to know the design aspect also, right? So if you ask a verification engineer, he should know Verilog, he should know VSDL, and then the languages which are needed for the verification, right? So if you ask a design engineer, he would be knowing only 2 languages. That's enough for him, right? Verilog, VSDL. But if you ask a verification engineer, it needs 5 to 6 language to make sure that he is a verification engineer, right? So verification is a tough job. It's means nobody will say thank you to the verification engineer. Everybody will say it's a good design. So all credit will go to verification, but all credit will go to the design. But backhand, we need to make sure that the verification is perfectly fine to make sure that the design is bug free, right? Because ultimately the design is the only thing which gets synthesized, right? And which gets into the wafer, right? Verification is not that part, right? So, but if there is no verification, there is no guarantee that your RTL is good, right? So it's like a salt into your curry, right? If there is no salt, the meaning of curry is waste, right? And if the salt is good, everybody will say the curry is good, right? Nobody will say that the salt is of that amount. So you can just map it to your image that verification is that salt into that curry, right? So we need a very good verification. Now, how an AI can help us into the verification, right? The same way AI helps the RTL design engineers, it is the same way that AI can help us into the verification aspect, right? So we can ask the verification, the AI to make a UVM test bench of it, right? how a how a UVM test bench is built, you should know how it is built, right? Now you know, then you can say, okay, I don't like this UVM test bench a bit. Can you revamp it or redesign it like this? So now the EA will also get the taste, okay, how this person needs an UVM test bench, right? So it will build the UVM test bench based on it, right? It will also have the FIFO. Now, if you have trained your agent with the RTL thing, right? The AI agent knows how an RTL was built, right? So now he knows that AI agent knows how an RTL is built. That AI agent now you can trade for the UVM, right? So when you say I want to test this particular functionality of an RTL, he knows, the AI agent knows how an RTL will build, right? So it can tell us that okay, this is how the RTL was built. This is how you can create a test bench around it, right? So the AI will help us in a tremendous form where we our imagination, so our imagination will be mature, but it happens that it will be mature after 2-3 months of working into that code, right? When you becomes mature in it, right? But if you ask AI, he can give you the envision or vision of a what would be after 3 months of the code, right? So that is the early verification advantage you can take from the AI, right? From the very starting, you can build a very mature test bench, right? So the duration of the duration of the test bench also gets decremented, right? And the quality of the test bench also gets improved, right? So this is how you can ask AI, right? Or you can ask AI to write assertions for you. You can ask AI to write FIFO, underflow, overflow test cases for you, right? You can ask AI, right, to have a coverage for you, which is called a functional coverage and the code coverage, right? Means you can ask ample amount of things which you know, right? If you need to know how a sequence is built, how a scoreboard is built, how a monitor is built, you can ask AI and AI will do it for you, right? So this is how a verification starts, right? Right now, as I said you before, what is the strategy of a verification, right? What we need to prove, we need to prove that the functionality of the RTL, the ordering, the errors are very good, right? We also need to test corner case scenarios. Like I will give you an example, right? If you are implementing a FIFO, let's suppose the right pointer reaches to the maximum point of it. After that, what will happen? Will it get swapped to the zeroth position, or will it be at the right and then it will start ignoring the packets, right? Now, if the RTL has not thought it through, it can happen that at the corner case where where the right pointer reaches to the maximum FIFO, it gets stuck there, right? It is not resetting. If the RTL is not verified it, if the RTL is not through to it, you need to make sure that that gets verified, right? So you need to think as the RTL engineer in a way where you want to verify it. So you need to create a test plan where that FIFO gets filled. And on top of that, if you send one more transaction, what happens? Whether that transaction is getting dropped, or whether when that FIFO gets filled, there is a signal gets asserted, or there is some error, or there are some interrupts, right? So these are the conditions which you need to test, right? Which RTL engineer would have not thought through, right? So that's why he said a verification engineer needs to know all those things before it comes to the verification, right? So you need to make sure that the latency, the throughput, right, of whatever the architecture had said before, that is working from your test case, right? So you can ask AI that this, what should be the formula I should put in order to get that performance, right? Or get that test cases, right? So AI can help you in building all those test cases. AI can help you in writing those UVM test benches, right? AI can help you in building sequences and everything, right? So if a schedule of a project without AI is 1 year, AI can do it in less than 2 to 3 months, right? So this is how, when I said it in my first slide, that the schedule impact with the help of the AI, we can beat it, the schedule impact, right? The much uh, lesser the schedule, the faster the chips will come into the market, right? So this is how AI help us in all those verification, right? So this is very technical to the UVM thing. I'm not sure whether the college students will understand this, but I just wanted to tell you just to at least in your subconscious mind, you know what it is, right? So UVM architecture at high level uh, is composed of the agents, right? So in agents, we have driver, monitor, and sequencer, right? We have sequences also, which is the stimulus, right? It can be directed also, it can be randomized also. We have scoreboard. So let's suppose if there is an RTL, right? But we need to make sure, right, whether the RTL is working fine or not. So we make our own RTL by ourselves, the verification engineers, right? So that becomes the expected, which we have written, and the actual RTL will give an actual code, right? So how a scoreboard will compare and match it, right? So all these things comes into our UVM architecture, right? And then there is a coverage, right? The functional thing, the code coverage thing. So the functional thing is uh, how clearly you have verified all the functionality of an RTL, right? So those gets covered into the functional thing. Now, traditionally, writing a functional coverage is very tedious, right? But now you can ask AI, right, to have that functional. So what does is, or what we are also doing this AI thing now. So what it basically does it, we feed the spec, right? We feed the micro architecture, and then from that micro architecture, AI will tell us what should be the functional coverage, right? Now when we get the list of the functional coverage, we can read it, we can see, okay, this functional coverage is fine. Now we can ask the AI that whatever the functional coverage you have written in English, now you can code it in UVM language, right? So you don't need to do anything. You just need to make sure that the whatever AI is writing, it's is good or not, right? And when with 2 or 3 iterations, you should be good enough that it is good, right? It can do the code coverage also, right? So AI is pretty much very powerful now, and it can help you writing all those things, right? So what you need to do is you just need to feed those macro architecture specs, any other documents from the web, right, or documents from your project, right, so that the AI knows what it needs to do, and based on that you can refine based on the comments or the prompts. Basically, the prompt word is a term where you write in English and say that this is what I need to do, right? So basically that is called a prompt, right? So basically, if you give a good prompts, your AI will give a good output, right? So this is a UVM architecture, how a test bench is built, right? So this is a very deep technical thing, how a scoreboard is matching, right? Out of order is, let's suppose if I give in a very, let's suppose if a person is driving, right? Or there are 2 people who are driving a car, right? There are parallel into things, right? Now a scoreboard need to see after 1 kilometer who crossed 1 kilometer milestone faster, right? Either the car A or car B, right? So it can happen that the car A cleared first 1 kilometer or 2 kilometer milestone first, but then the car B took overtake, right? So it needs to have a continuous looping of the out of order. So basically, this is the concept of out of order, right? Right? That before coming to the finishing point, it can have many more sub points when it before it gets finishes, right? So that's the concept of out of order, right? So there can be multiple milestones and all that, right? So how to build that scoreboard? It is one of the complex scoreboard which I think it is asked during the interviews also, right? So now we had to have hands-on of 3 4 experience to get to know what is out of order scoreboards, right? But now if a grad student or an engineering student just type into the AI, give me the code of the out of order scoreboard, it will give to you, and then you can ask AI that you can means explain me each and every step you have written, right? So the AI will explain to you that because of this I have written this code, because of this. So uh, the uh, the college grad which had got this information when he would have been 3 4 years experienced, having read multiple of books to get that experience, now you can get that experience with a single prompt if you know how to talk to the AI, right? So that is what the power of AI is, right? It's tremendous if you know how to use AI in your daily works, right? So yeah, so this is how scoreboard gets used, right? So yeah, this is very technical, and I have told you, right, how this gets used, right? So now the second aspect of the verification is the coverage, which I told you earlier, that there are code coverage things, functional coverage things. AI can make sure that you have code coverage things written, the functional coverage things written, right? So it can help you a lot in implementing that code. And while it is implementing that code, you can apply your mind somewhere else, which is critical to that particular project, right? So you can do all those things into it, right? So this is how AI works, right? So now, which I've told you earlier, right? This scripts, this PPT or this slide tell us, right, that how AI accelerates our debugging, right? So let's suppose if you run a test case which you have written in the UVM and that fails, right? Now, if you're a college grad, you don't know anything, or you're new to the project, you don't know anything how to debug it, right? But what you can do is you can give that log, a test log, basically a logs gets created into a simulation, and then you feed it to the AI saying that what is the data flow, right? So instead of spending your time to understand what is the data flow of that project, right, with 4 or 5 days or month or two, you can get it into in 2 days, right? When you ask the AI that what is the data flow, and then AI can explain you what is the data flow, right? From that you can understand, okay, this is where it is missing, right? Because you would have read it into the spec and all that, right? So the debug time, which would have taken traditionally for a week or so, now it gets reduced to a day or two, right? So this is where the verification speed also gets increased, right? So this is all with the help of the AI we can do, right? Now, as I told before, right, there are two parts of the verification. One is the functional verification, and one is the formal verification, right? So formal verification came very recently into the verification cycle, right? So the formal verification, what it does, it we do not need a test bench, right? So basically, a formal has its test bench, own test bench, where it randomizes everything, and we just need to write assertions, right? But then that formal verification is as good as what you have implemented those assertions. If those assertions are not good, your formal will be of no help, right? Now you can ask AI that how to implement an assertions, right? So AI can implement good assertions for you, and then you can just review, right? If you know, okay, all these things need to be there, you just feed to AI, okay, I need all those assertions. The assertions can be implemented by the AI, right? You do not need to know the syntax of it. And if those are good assertions, your formal verification will be very good, right? So this is how AI can help you into this. And the formal verification needs a tickle script. Now, so let's suppose you don't know a tickle script, right? So normally people doesn't go into that path which they don't know, right? They will say, oh, it's difficult and all that, right? Because you don't know that particular script. Now, no need to worry, right? You just tell AI that I need a tickle script with all those things, parameters. Tickle script will be created by the AI, right? And you just need to refine and incrementally add that based on your needs, right? And your tickle script is ready. Your assertions are ready. You can go and verify with the formal verification, right? So that is the amount of easiness which AI has provided onto us, right? So now the digital part of verification is done, right? Now I will have some, so this is not my area of expertise. So I will give a very quick outlook on this, on how the AI works, right? So basically AI works on the analog, right? So this is the digital part. Now the chip also has the analog part, right? The clock part of it, right? The how a clock gets generated. It gets generated by the oscillator, right? Now how that oscillator gets the voltage, right? Voltage is in points, 0.2, 0.4, 0.6. Digital is only 0 and 1, right? So these are the analog parts of it, right? How the clock, how the voltage, what how. So when you architect a particular design, right, those are the analog circuits. So in college there is a there would be some subject called analog circuitry or signals and systems or DSP, right? So if you are very good in that, you can go to analog part of it, because those are the circuitries, basically how the current will flow, right? What should be the voltage regulations, where the capacitors should sit, where the resistors should sit, right? And all those things, right? So if you're good in those, you can opt for the analog engineering part, right? So this is how the analog works, where the current flow, the power fluctuations, the ground level, how a circuitry is built, right? So let's suppose if your battery gets heated up, should it not blow? Why you are not getting current in your mobile, right? Because of the current flow and all that, right? right? When we say nowadays a mobile are there with that 1 minute of charging, your battery gets charged, like, so those are the analog parts of it, right? The how the power gets fluctuated into the battery, why the leakage is less, what is the power flow, right? Those comes into the analog part of it, right? So this all comes into the analog. So all this, yeah, means I'm not the expert, but if somebody is done onto it, AI can definitely help us in drawing the circuitry, what should be the power, right, and all those, right? So this brings to the analog part of it, right? Now, how an AI uh, implements that, right? So basically, all those which I said you again, right? It summarizes the spec, trace the test, RTL, refactor, lint fixes, UVM generation, debug. Everywhere AI help us, right? In every aspect of our coding, right? Uh, yeah, I think this is traceability. Yeah, trade-off. So basically, this I wanted to cover, right? There are pros and cons for every thing, right, of the architecture, right? So if the spec says the latency should be, let's suppose, 32 nanoseconds, right? But the RTL is giving only the minimum is only 40 nanoseconds, right? So how you would do it, right? So all that comes into your DV. You need to make sure that the latency, throughput, the area, power, observability, and all those comes in your design verification, right? So verification, when we say, it's basically design verification, right? So AI can help us summarize all those by reading the spec, by reading the RTL, and it can tell that, okay, the maximum can be come by this thing, right? So you have a way to understand, okay, these are the latency and the throughput, right? And then this you need to be tested, right? So basically, these are the things which can be done by the DV with the help of the AI, right? Ordering and all those RTL gates. Okay, now we are coming on to the backend part of it. So I will just give a preview of it. So whatever the RTL gets implemented, right, those RTL gets turned into flops. Now there are tools for that to do that. Now what happens, where the bug comes is, now suppose you have written a case statement, right? But that tool understands that case statement and it turns that into a latch instead of a flop, because you have written a case statement and you are not written default, right? So what it happens, instead of FIFO, it turns into a latch, right? Now, by the help of the AI, you can tell that if, let's suppose you have written a case statement and not default, you can tell AI, right, that if this is the case, right, give me an error and give me an also an data why this was converted into a latch or not flip flop, right? So if you tell all these things to AI, the moment this gets turned into a latch by the tool, AI will flag an error, right? So these are all the things which are done into the RTL gates, right? So I think, yeah, now I think this all things would have been covered in the layout somewhere or in the manufacturing. So as I told before, right, low power is the thing, is the latest thing, right? The less power it consumes, the good the chip is, right? So I think this is terms of the, and now there is a low power verification also. Like what we do is a functional verification, but there is a very specific branch the people get employed, that is the low power verification, right? So in that, what happens, they just need to test what is the power of that particular chip, whether it is low, whether it is high, whether it is going through the uh, throughput or not. So that is the low power verification, right? So this I have already covered, analog, AMS modeling, how AI helps into it. Now there are some chips where analog and digital both are working, right? So these are the things how AI can help us into is like DAC converter, digital to analog, analog to digital, right? The handshake, the metastability, saturation, clipping. Clipping means if a voltage needs to go to the peak and come back, it doesn't go to the peak, right? And it gets saturated and then it starts declining. So it means the peak gets clipped, right? Now why it is clipping? Because of some magnetic interference or the current or something, right? So all these things can be verified with the help of AI also, right? Emulation, I have told you, validation is there. And then this is the playbook, right? Performance, I have told you, right? If we need 51.2, 100 Gbps performance, but the performance coming 80, 90, right? You can tell AI you can feed the design, right, design files into the AI, and then AI can let us know that these are the designs, right? So these are all the things which we can do via the AI, right? I think, yeah, coding parts gets complete, right? This is the last DB sign off, right? So basically, when can DB say that it is good, right? That the RTL is good, right? When the functional coverage goals are achieved, the exclusions are justified, the bug which all have been filed by the DB design has been solved, right? All this clock domain crossing, the analog mismode signal, right? The low power, all those have been signed off by the architecture, micro architects, and the RTL guys, right? And then the regression is 100%. So what is regression? So regression is basically a test suite which verifies the feature. So if that test is passing with all the self checks and coverage, we can safely say that it has been verified, right? So this is where the coding happens, right? After this coding, it's mostly on the backend side, right? The layout things, the synthesis thing. So I think I won't cover that. I think that session has already happened. So I think, yeah, that's it from my side. Now I'm open to questions if there are any.
Deepak, one question was raised by Ms. Harsha. That was, which language must know to do verification rather than HDL?
Very good question. So system Verilog, UVM, and you should know C. These three languages, if we want to go into the verification domain.
Participants, any more question?
Sir, please repeat.
System Verilog.
Okay, sir.
UVM, the full form of UVM is Universal Verification Methodology. And then you should know C also, because C is the basics of the means if you know C, you can easily have the knowledge of SV and UVM. So you should know C and C++ also. System C is not required, but yeah, C and C++ is required.
Okay, sir. Thank you, sir.
Thank you, Harsha. Any more questions, participants?
Hello.
Yes, please go ahead.
Okay. Sir, I would like to ask you, in fabrication, this process is agile or waterfall? That means I
Ma'am,
mean to say,
I am not a expert of fabrication, so I'm sorry, I cannot answer that question. Fabrication, I'm not. I'm not sure. I am as new as you only. I have never worked on the fabrication part of it, of the chip.
another, that can we if I give as a customer, if I give a specification, can I is it I have liberty to change my specification?
Yeah, you can change your specification any point of time, right? Because after specification, your micro architecture spec will be coming up. Then you will be designing the RTL, right? Now, at that point of time, if you come to know that, let's suppose if your battery is not working, right? Or if you're not able to move, right? You can change your specification. But changing the specification at the end means you need to again invest your time from the scratch, right? So you need to make sure that your specification is good enough so that your time investment has some value, right? The ROI. Otherwise, if it is done on the later stages, again, all those time will be lost, right? Because again, the RTL needs to change. Again, the macro architecture needs to change. The verification also needs to change. So yeah, you need to be make sure that your specification is good. It can be changed at any point of time, but then that time invested of that duration is a waste.
That means it's agile process. Fabrication is agile.
I'm not sure what process you can say, but yes, yeah.
Answer, sir. Thank you so much. And another question is, which software you use to write down the test cases?
Yes. So basically, I told you, right? Those are three tools which have been given by the Synopsys company, Cadence company, and Siemens. So in different company, different tools are used. As of now, I'm using Verdi. So Verdi is the tool which we write test cases, we simulate the RTL, we simulate the design, or we write our test bench.
Okay, thank you so much. That means a lot.
Yeah, thank you.
Participants, do you have any more questions? Yeah, Tejaswini, please you unmute your mic.
Sir, if you want to relate with VLSI and AI, what is the basic requirement or basic things? As you said, system Verilog is required. And what are the basic things required if you want to relate with the AI and VLSI?
Ma'am, your voice is very low. I'm not able to hear your question correctly.
So how to relate AI with VLSI? What are the basic requirement required?
Your question is how to relate AI with VLSI? Is that the question?
Yes, sir. Yes, sir.
Yeah, I think the first thing is you should know the basics of VLSI, right? So if you want to ask any questions of VLSI, at least you should know the basics of VLSI, because if the AI gives you any sort of questions, you will not be able to understand if you do not know the concepts of VLSI, right? So what will I suggest is at least you should know the concepts of VLSI, why VLSI is used and where VLSI can be used, right? And on top of that, you can build your knowledge by asking questions to the AI, right? So it's not that you don't know anything and you just start asking questions to the AI. You won't understand also what AI is giving answers, right? So at least you should have a very basic knowledge of VLSI, the semiconductor, at least the whatever the subjects you have in your colleges, right? Like at my point of time, there was some CMOS VLSI subject in my FEPSEM, right? So if you have the knowledge of that, pipe diagram is the knowledge, right? The CMOS, the NMOS, I think you have all those subjects. So if you have the basic knowledge, you can start on top of that. So what you do is, if you have the basic knowledge, have the PDF or the software copy of all those books, right? And give that input to the AI, right? Now, let's suppose if you want to understand the pipe diagram. So you can ask the AI that this section, you read that section, right? And my understanding is this, what is your understanding and where is the difference in that understanding, right? So with that thing, you can start getting more brains, right? And then you can be much more mature in the pipe diagrams or whatever, as per the AI knowledge and all that, right? Because all this knowledge are very scattered in internet. That's why there is a very low level of skill set of the electronic people in this core, right? As per the article, only 3% of electronic engineers comes into the core, right? Rest are all in computers. Why? Because the knowledge gathering, the books, the foundation is not there into the students, right? So they prefer to go into software rather than into the hardware, because there is no knowledge. So you can build your knowledge based on these books, and then you can start asking questions to the AI to build your knowledge incrementally on it.
Thank you.
Any more question? Yeah, Dr. Sahin.
Yeah, Deepak, sir, I just want to ask a very simple question. Like, since 5 to 10 years, I'm hearing of fabrication and work which is going on in China. So, in this time, we are expecting that we will be having the same. We will be at par with China in terms of manufacturing of chips and all that.
Sir, your voice is
Can
broken.
we?
I am
Can
not
you
able to understand.
throw some light on that?
Sorry, sir, I didn't understood your question. Can you repeat?
I repeat.
Yeah.
Since last 5 to 10 years, we are hearing that a lot of manufacturing and this kind of chip fabrication work, IC work is taking place in China, and especially I just want to know the Indian scenario, like China, or maybe competing with China in the future. Is there this kind of scenario expected in the future?
No, no, I think Indians are very, they are very, very, means China is leaps and frogs ahead of India. I don't think so. The Indian government or the Indian structure or the Indian students, means it's not up to the students. Students have that thing, but as I said, right, the very first time investment into the fabrication is very high, right? And there is only single company in this world, will you believe it, which can do the fabrication, that is TSMC in Taiwan. Not US is also able to do that, right? So it's a very complex process, and the first time investment in those manufacturing is huge, right? Now if you see India's GDP and per capita, India cannot, or Indian government cannot, though it is starting to have that initiatives, but we are years back with respect to China. Where we can compete, I can tell you, in the fabless engineering. Instead of manufacturing, if we concentrate more on the fabless, like Israel is doing, Indians are already ahead, but we do not have the companies, right? All companies are US or Russia or Germany based, right? Or even Chinese based. So if the government can foster the startups, right? If you see many of the startups, we can give at least a competition in the fabless manufacturing, rather than checking the faculty this manufacturing, because it requires a lot of water, also a lot of land. There should be no dust, right? The temperature should also be controlled, so it needs a lot of electricity also, which I don't think India has that, right? So yeah, instead of manufacturing, we should concentrate on fabless manufacturing. This is my knowledge.
Thanks a lot, Deepak. Thanks a lot.
Yeah.
ಹೇಳಿ ಕಾಶಿಪ್, ನೀ ಹೇಳ್ಬೇಕು ನಾವು ಕೇಳ್ಬೇಕಪ್ಪ ಇವಾಗ.
Dr. Mahesh, would you like to ask
ಕೇಳ್ತೀನಿ
anything?
ಅಂದ ಅವ್ರು ಸಿಕ್ಕಿಲ್ಲ ಇವತ್ತು. ಅದೇ ನಿಂಗೆ
Hello?
ಮಾಡ್ಬೇಕಂತ ಆಕ್ಚುಲಿ.
Hello?
Yeah, hello.
ನಾನು ಏನಾದ್ರು ಮಾಡ್ತೀನಿ ತಗೋ, ಕೇಳ್ತೀನಿ. ನಾಳೆ ನಾನು ಅಲ್ಲೇ ಇರ್ತೀನಿ. ನಾಳೆ ನಾನು
I think there is some noise.
Excuse, this is Dinesh from Dinesh. Can you suggest any centers that teach VLSI better than us? Because we are in basic level. We are still in book level. We are not up to the level of industry.
Sir, there are many. So you are saying VLSI in terms of real hands-on institutes you are asking?
It's not like a hands-on. We are in a basic level. We are not in the level of industry.
Right.
Still, I am from Tamil Nadu, from Mana University. Still, we are in we are in front-end, like only about Xilinx coding. Still, AND gate, OR gate, or flip-flops level only we are. Yeah, we are giving to our students that much input alone. So if any center that, because I have done my physical design engineering in Bangalore in time to market company. After that, I have changed my domain and I have been in teaching for last 10 years. So like that, in present, any centers like Sandipani in Bangalore, like that, any centers are there to support our students.
Many centers are there, right? So I am living in Gujarat, right? So after college, I also didn't get a job, right? So I did I think from ITRA, right? It's in Ahmedabad. It's in affiliation with E-Infochips. So I did my coaching over there, right? And then I got a lot of knowledge on SV UVM. So as in, I think in Ahmedabad it is ITRA. In Bangalore, there are lots and lots. So like Sandeepani is there. If you search in Google and AI also, you will get a list of institutes, but you just need to make sure that is not fake, right? So Sandeepani is one, Aitra is one, which it's been 15 years, but these are the now there is one more ASIC design. Now I think the concept have changed, right? So now what happens is there is a startup. Now startup needs some funding, right? So what it does, it opens an coaching institute, right? So what they does is the coaching institute, they take money from the students, so that they fund it to their company, and then they teach those students, right? And then they uh, then if there are some levels, right, like if 100 students are there, they know that this 10 students are working fine, right? What they do is they place that students into their own company, right? So if you ask them, they can come to your engineering college also and give the coaching, right? But that needs to be a dedicated coaching of 6 to 8 months to 1 year, right? It's not 1 or 2 days. It's a vast language we need to understand, right? It's a altogether different concept. So if I would urge that if our ministry thinks that those things should be there, they need to provide that subjects into the electronics, right? Instead of only basic flops and all that. So if that thing is given into like if C is the language, they can introduce 2 more languages, right? Where System Verilog or VSDL, right? And if the students have this basic knowledge via these institutes, they can be selected into any of the companies.
Okay, thanks, sir. Thank you, sir.
Yeah.
I hope participants are satisfied with Mr. Deepak Kaushik. So before going for the vote of thanks, we should turn on our cameras to have a memory. Please turn on cameras. Dear participants, will you please turn on your cameras to have a great memory. So thank you very much, Mr. Deepak Kaushik, for such an informative and insightful session on chip design flow from specs to code with AI. Your clear explanation of the end-to-end chip design flow and the integration of AI and various stages from specification to code has provided valuable clarity and practical understanding to all our participants. On behalf of V.V.P Engineering College, the Atal FDP Organizing Committee, and all the participating faculty members, I extend our sincere gratitude to you for sharing your expertise and for sparing your valuable time with us. Thank you once again, sir, for your meaningful contribution to today's program. Thank you, sir.
Thank you. Thanks a lot. Thanks a lot, everybody.
Participant, I had shared a feedback link with your email IDs. Feedback link of both the session with your email IDs. Please check it and fill it. Thank you.
Yeah, thanks. Thanks,
We'll be
everybody.
meeting tomorrow. Yeah, we'll be meeting tomorrow sharp at 6.
Thank you, sir.